Hello students, welcome to IMS Academy. Hello students, welcome to IMS Academy. Myself Jeprakash, lead mentor of EC branch at IMS Academy. Yesterday we started the first session regarding digital circuit subject regarding gate score booster session. In that session we have discussed the important and most important concepts related questions that we have covered regarding first three chapters like number systems and codes, Boolean algebra and K-maps, and then logic gates. Okay, so in this particular session, this is the second session regarding digital circuit subject, right? In this particular session we are going to discuss the questions related to the important and most important concepts, and of course important models also with respect to coming gate exam. We are going to cover regarding remaining 4 chapters of digital circuit subject like combination circuits, sequence circuits, and then data converters, and then logic families. Okay, so regarding the last 4 chapter questions we are going to discuss in this particular session, just like yesterday's session, which is common for 4 branches: EC, electrical, instrumentation, computer science. Similarly, in this session also, whatever the questions I am going to cover up to sequence circuits, it is a part of the gate syllabus for CS branch, whereas for electrical branch up to 6th chapter, whereas for EC and instrumentation up to the last question that we are discussing in this particular session. Okay, right. Whoever not yet attended that session either live or whoever not yet watched that session in the recorded, no issue, you can kindly watch that session in your free time. Okay, and whoever visiting our YouTube channel very first time, kindly subscribe our YouTube channel. Okay, and then click on the bell icon so that you will be getting all the instant notifications. All of you can kindly like and share this video link with all of your friends so that they also will attend this session either in live, or whoever cannot attend this session live, no issue, at least they can watch this session in the recorded form later. Okay, so definitely each and every student, whoever going to write coming gate exam, gate 2026, if they belong to any of the branches like EC, electrical, instrumentation, computer science, definitely they can check their confidence regarding digital circuit subject and they can maximize the marks in the upcoming gate exam. Okay, right. And whoever not yet joined our Telegram channel, so the link is provided in the description of this particular video, so all of you can kindly join in your free time. Okay, you are getting all these important updates in our Telegram channel. Okay, right. So already we have shown regarding the weightage of the subject digital circuits in the yesterday session also. Just for reference, I kept here. Okay, as I mentioned already, we have discussed in the yesterday session, in the last session, we have discussed the questions related to first 3 chapters, and in this particular session, we are going to focus the questions related to the remaining 4 chapters. Okay, with respect to branch wise, you can see the like which chapters belong to the respective branch, and coming to the weightage also, you can have the reference. Okay, right. I hope all of you are eagerly waiting for the session, so let us start. Yeah, now we are going to discuss the questions related to the 4th chapter, that is combinational circuits. Right. So all of you can give a try. This is a question regarding ripple carry adder, right? Ripple carry adder or parallel binary adder regarding worst case delay. Regarding worst case delay or maximum propagation delay, all are one and the same. So in this question, they have given the data regarding ripple carry adder. You are having it is having 8-bit ripple carry adder, right? And regarding each full adder, in order to produce the respective sum, it is taking 10 nanosecond. In order to produce the carry, it is taking 8 nanosecond. Okay. So I hope all of you know regarding the block diagram of 8-bit ripple carry adder. In that 8-bit ripple carry adder, you are having 8 full adders. Okay, each full adder, in order to produce respective sum, it is taking 10 nanosecond, and similarly, in order to produce respective carry, it is taking 8 nanosecond. Now the worst case delay you have to find out. I hope all of you know the respective formulas. When you are having like n number of stages, at nth stage or last stage, okay, you have to find out the sum delay and you have to find out the carry delay. So among those two, whichever is larger, definitely that is going to be the final answer. All of you can give it a try. Yes. So just observe. Okay, I'm just writing the data in short. So here number of bits are 8. That means number of stages you're having 8. Okay, fine. Now sum delay of a full adder given 10 nanosecond. Sum delay given as 10 nanosecond. And carry delay given as 8 nanosecond. This is with respect to a full adder. Okay, for every full adder, same delay with respect to sum and with respect to carry. Sum delay is 10 nanosecond, carry delay is 8 nanosecond. Now, since you are having 8 bits or 8 stages, at last stage, that means 8th stage, you have to find out regarding sum delay and then carry delay. So coming to the sum delay, at nth stage, the formula is Ts plus n minus 1 times Tc. Ts plus n minus 1 times Tc. Whereas carry delay at nth stage is n times Tc. N times Tc. You are having n value Ts and Tc. You can substitute here and then you are getting corresponding sum delay and carry delay at nth stage full adder. So Ts is 10 nanosecond. Then 8 minus 1, carry delay is 8 nanosecond. Similarly here, n value is 8, carry delay is 8 nanosecond. Yeah. So here in this case, you are having 10 nanosecond as it is. 8 minus 1 is 7, 7 8s are 56. So 56 plus 10, that is 66 nanosecond. Okay, here 8 8s are 64. You are getting 64 nanosecond. Okay, so sum delay you are getting 66 nanosecond, carry delay you are getting 64 nanosecond. So among these two, the largest value obviously 66 nanosecond. So this is the final answer. Yes, very good, Ricky. Very good. Excellent. Answer for this question is 66. Yes. I hope all of you understood regarding this question. Okay, now I'm showing the next question. So this question is also regarding the propagation delay only. Okay, so regarding a particular full adder. Okay, the propagation delay of XOR gate, AND gate, OR gate. In this question, you are having the delays of logic gates. Propagation delays of XOR gate delay given as 20 nanosecond, AND gate delay given as 10 nanosecond, and OR gate delay given as 10 nanosecond. Okay, right. If the maximum propagation delay for producing sum and for producing carry at the output of full adder are Ts and Tc. See, in the earlier question, they have given directly the Ts value and Tc. Okay, but in this question, you have to calculate the respective sum delay and carry delay of a full adder. Okay, inside the full adder, I hope all of you know the circuit with the help of the logic gates. Okay, in order to produce the sum, in order to produce the carry. So here in this question, you're having respect to logic gates delay. You draw the circuit diagram of full adder, and with the help of propagation delays of the logic gates, accordingly you can calculate in order to get the sum, what is the maximum time it is taking. Similarly, in order to get the carry, what is the maximum time it is getting. Okay, in order to get carry, what is the maximum time it is taking, you have to find out. So among that, with respect to that, regarding carry delay, 2 choices, regarding carry delay, 2 choices, regarding sum delay, 2 choices. So at most here one option can be correct, here at most one option can be correct. This is a MSQ question. Yes, Ricky. Yeah, regarding EMFT subject, it is there in the pipeline. So regarding the EMFT subject, gate score booster session will happen most probably in the next month, December. Okay. So in this month, yesterday we started with digital circuit subject. So yesterday one session over, today is the second session, right? Similarly, in the next week, we are having gate score booster sessions, live sessions regarding network theory subject. 2 sessions we are having, just like yesterday and today, Thursday, Friday. Similarly, next week we are having Thursday, Friday regarding network theory subject. After that, we are having like, in this month, further planned live sessions, sir, regarding signals and system and then control system. Okay, in this month, 4 subjects we have planned. Similarly, for other subjects, whatever possible, we have planned in the upcoming month. Okay, so definitely EMFT will come, okay, in the next month. Yeah, thank you for asking for that subject. So definitely already we have planned, so it will come in the next month, right? Yeah, so in this question, I hope all of you know the circuit diagram regarding full adder. Regarding circuit diagram of full adder, in order to get sum, you require 2 XOR gates, right? In order to get carry, here you know the formula like A XOR B into C in plus AB. So accordingly you require the respective logic gates. Okay, so I hope all of you know this circuit diagram is nothing but XOR gate, AND gate. This combination is nothing but half adder. And similarly here, XOR gate, AND gate combination is nothing but half adder. For implementing a full adder, we require 2 half adders, and in addition to that, we require 1 OR gate, right? Okay, fine. Now, in this question, XOR gate delay is 29 seconds. Okay, just for reference, I am mentioning here, XOR gate delay is 20. Next, AND gate delay, OR gate delay, both are same, that is 10 nanoseconds each. each. So each logic gate, the respective propagation delay I have mentioned inside the logic gate for reference. Yes, very good, Ricky, very good. So here, in order to get sum you are getting at the output of this XOR gate. This XOR gate is having 2 inputs. Okay, one input you are getting, one input is nothing but the direct carry input. Okay, this input is available at 0 nanosecond. This input you are getting at 0 nanosecond. There is no delay, because all these inputs A, B, C in you are giving at time 0 nanosecond. Fine. That means this input directly you are getting. But for this XOR gate, one more input is there. That input is output of this XOR gate. And so AB you have given at 0 nanosecond, but this XOR gate is having certain delay. So accordingly, this output you are getting at 20 nanosecond. At 20 nanosecond. Now just observe, for this XOR gate, 2 inputs are there. One input you are getting at 0 nanosecond, but other input you are getting at 20. So obviously we have to wait for this input, because we are calculating for maximum propagation delay, right? So now, in order to get the output at the XOR gate, so here 20 nanosecond and here 20. So together 20 nanosecond plus 20 nanosecond, that is 40 nanosecond. So that means the sum output you are getting at 40 nanosecond. That is the maximum propagation delay after you have given the inputs for the overall circuit. Okay, now similarly we have to find out regarding the carry, how much time it is taking. Now here OR gate, just like this XOR gate, it is having 2 inputs. Okay, one input is nothing but output of this AND gate, right? AND gate is having delay of 10 nanosecond. So here output you are getting at 10 nanosecond. The same output we have connected. That means here same delay, 10 nanosecond. Fine. Now what about this other input? This other input is nothing but output of this AND gate. And for this XOR gate, whatever the 2 inputs you are having, exactly same 2 inputs we have connected here for this AND gate. That means among these 2 inputs, we have considered this delay. So definitely we will be considering same delay here, 20 nanosecond. Then after that, this AND gate is having delay of 10 nanosecond. So together 20 plus 10, that is 30 nanosecond. 30 nanosecond, right? Now just observe, for this OR gate, two inputs are there. One input you are getting at 10 nanosecond, but other input you are getting at 30 nanosecond. So obviously you have to wait for this particular input. Obviously you have to wait for this particular input, right? Right. So now here this OR gate output you are getting at what time? 30 plus 10. 30 plus 10. That is 40 nanosecond. So this is your carry delay of a particular full adder. In this particular example, both sum delay and carry delay both are one and the same, that is 40 nanosecond. Okay. So now you just observe, sum delay, carry delay both are 40 nanosecond. So that means option C and option D both are going to be correct for this question. Option C and D both are correct. Yes, very good, Ricky. Yeah, next question, theoretical question. I hope all of you can answer this question easily. The question is of MSQ type. All of you can give it a try. Yeah, just observe here. Choose the correct option or options. Either single option or more than one option can be correct. So you have to choose accordingly the respective correct options. Okay. So here the first choice you're having, decoder can be used as demux. Yes, we can utilize. Decoder is having lot of applications. So here functionality wise, decoder and demux both are different. Decoder means what? At the input side, you are having coded form. With the help of this combination circuit, we are performing reverse operation, that means decoding. And with the help of demux, what we are doing? We are getting single input line. With the help of selection lines, we are connecting that input line to one among the 2 power n outputs. That means this demux is acting like a switch. Okay, serial to parallel converter we can say, right? So decoder, demux, functionality wise different, but internal hardware circuit point of view, both are having one and the same. Like for example, you can consider 2 to 4 decoder. So there you are having internally 4 AND gates, right? And for every AND gate, 2 inputs are there. Okay, right. And then if you are considering enable also, accordingly you can consider, that means for every AND gate you are giving total 3 inputs. And then extra you may require 2 NOT gates. Similarly regarding demux, 1/4 demux if I consider, then you are having internally 4 AND gates, and every AND gate require 3 inputs, among which 2 are the selection lines, and 1 input will be the serial input. Okay, and here also we require 2 NOT gates. That means whatever the here internal hardware circuit, here also one is the same. Since hardware circuit point of view exactly same, that means if you are having decoder, if your requirement is demux, you can utilize same decoder as demux. Similarly, if you are having demux with you, and if your requirement is decoder, then you can utilize same demux as decoder. Okay, so that means decoder can be used as demux. Similarly, demux can be used as decoder. Okay, so that means option A is correct. Next, decoder can be used for producing minterms. Yes, this is correct. How it is correct? Because when you are keeping enable value 1, whatever the outputs you are getting, output expressions at the decoder, those expressions are looking exactly similar to the minterms notation, right? So with the help of normal decoder, we can produce the minterms. Okay, right. Now, let us read the last one. After that, we'll discuss here. Okay, here whatever the decoder I have considered, very simple. You are having some coded form at the input of the decoder. Based on that particular, whatever the binary code you're having, that number when you convert in decimal, the respective output, okay, we are making as 1. That is a normal decoder or active high output decoder. Now if you want exactly ulta, you can make, that is the combination that you are getting, active low output decoder. So when you are saying here with the help of this normal decoder or active high output decoder, when you are getting min terms, obviously the complement of min term is max term. So with the help of active low output decoder, we can produce max terms. Yes, this statement is also correct. Right, now let us see regarding option C. I hope all of you can answer this one. Here in this question, 3 statements are there with the help of decoder. Okay, regarding those 3 statements are correct that I have discussed. Now I am giving chance for all of you. Try your level best whether option C is correct or not. Just confirm in the chat. Yes, mux is a universal element. Yes, it is correct. Mux is a universal element. See, with respect to logic gates chapter, NAND gates and NOR gates are the universal gates, because with the help of NAND gates or with the help of NOR gates, we can implement any Boolean function. Exactly similar way, with the help of a mux, you can implement any Boolean function, provided one condition. One condition is there. If it is satisfied with the help of single mux, you can implement any Boolean function. What is that condition? Very simple. Whatever the Boolean function that you want to produce, in that function, how many variables you are having? Exactly same number you have to consider with respect to the number of selection lines of the mux. Then with the help of single mux, you can get the respective Boolean function which you want to generate. Okay, but if the number of variables of that Boolean function and number of selections of the mux not matching, then you may require extra muxes. So definitely you can implement overall that particular function. Mux is the universal element. Yes, here in this question, all the 4 statements are correct. Whatever the statements here you're having in every choice, so all the 4 statements are correct. So that means for this question, total 4 choices are correct: A, B, C, D. Okay, right. Yeah, this is the question based on decoder and encoder. Here you're having 3 to 8 decoder, and here you're having 8 to 3 encoder, and outputs of the decoder connected to the inputs of the encoder in some fashion, okay, or some configuration. You can observe the like which output is connected to which input, etc. Now overall circuit you have to identify. Whether it is performing gray to binary or binary to gray, binary to XS3 or XS3 to binary. All of you give it a try. I'm giving time for everyone. I'm keeping the timer 1 minute. All of you try your level best. Yes. See, here you just observe overally, okay. For overall circuit, you're having number of inputs are 3 and number of outputs are also 3. Okay, whenever you don't know, okay, like what is the overall question answer, no problem. Since you're having choices, you can verify option by option. And whenever you are getting one question or circuit diagram with the help of 2 different concepts or 2 different circuits, etc., don't get panic. analyze stage by stage. Okay, and if you're good at basics, principles regarding that particular concept, then definitely you can solve the question easily. Okay, but you should have the patience and you should know the basics wise clear, then only you can solve the question correctly. Okay, so here just observe. Yeah, so here you are having normal decoder, yes or no? See, if you are having bubbles here, then it is the active low output decoder. If bubbles are not there, it is the active high output decoder or normal decoder, one and the same. Okay, so for a decoder, you know that whenever you're having some code information, say for example 3-to-8 decoder, that means 3 inputs are there. So when you're having 3 input lines or 3 bits or 3 variables, you are getting 8 combination of zeros and ones, right? So at any time, one among these 8 outputs will be equal to 1 based on the code or combination of zeros and ones that you have kept here. Okay, that means remaining all the outputs will be 0, right? Okay, now just observe, here you are having encoder and here you are having 8 inputs and number of output lines are 3. Okay, so this is the normal encoder. Okay, for the normal encoder, what is the mandatory condition? At any time, only one input should be high. Then only you will be getting code correspond to the respective input. And since you are here in this circuit, the outputs of the decoder only connected as the inputs for the encoder. So whatever the condition here required, that condition is already taken care of with the help of this configuration. Right? Okay. Now we have to decide whether overall circuit is like among the 4 choices, which one is going to be correct. Okay. Now, just by observing the circuit, straight away you can eliminate 2 wrong choices. Among these 4 choices, which 2 choices we can eliminate? Any guess? Without using pen and paper, just by looking at the circuit, you can eliminate 2 wrong choices. Even if you are able to eliminate 2 wrong choices, that means you are on track. Yes, just observe here. Just observe. Here you are having XS3 code. See, I hope all of you studied regarding XS3 code in the first chapter. XS3 code we have defined for decimal digits, and in the XS3 code for representing 0 to 9, any single digit, we require 4 bits. Yes or no? 4 bits. So do we have 4 lines here or do we have 4 lines here? No. That is the reason we have to eliminate straight away B and D. Straight away we have to eliminate B and D. Because for XS3 code is nothing but BCD code plus 3. So in the XS3 code, just like in the BCD code, you require 4 bits. Since you don't have 4 input lines, similarly, you don't have 4 output lines. So that is the reason we have to eliminate these 2 choices straight away, without any doubt, without any hesitation. Okay. Now 2 choices are left over: gray to binary, binary to gray. And generally, many of the students will do silly mistake here. Here, one of the important note point, either for 3 inputs or 4 inputs. Okay, generally you will be getting question for 3-bit or 4-bit, like that only. Okay, because more than 4-bit also they can frame, but in the GATE exam they won't ask. The reason is it will be time consuming. Okay, so they never frame any question intentionally like time consuming. Rather, they will keep some logic, if at all, if they want to frame any typical question, etc. Right. So regarding binary to gray or gray to binary, either for 3 inputs or 4 inputs, don't verify first 4 combinations of zeros and ones, because first 4 combinations of zeros and ones, with the help of any of the combination, if you want to verify or if you want to decide overall circuit whether it is binary to gray or gray to binary, you cannot get the conclusion, because it will satisfy if you are treating input as binary, output as gray, or if you are treating input as gray, output is binary. It will satisfy for first 4 combinations. Okay, in your free time you can cross check whether it is correct or not. Okay, but for the timing I have given that hint point. But whatever other than starting 4 combinations, whatever remaining combination you are having, with the help of any one combination, other than first 4 combinations, straight away you can decide whether the given circuit is acting as binary to gray or gray to binary. Okay, for the timing I am considering one combination, say for example 100. See, starting 4 combination are what? 0 to 3, 000, 001, 010, 011, right? So first 4 combination we should not Verify. With the help of remaining 4 combination, any one combination you can easily decide overall circuit whether really acting as binary to gray or gray to binary. Now 100 I have considered. 100 is nothing but what? 4. So that means OP4 will be 1. OP4 will be 1. Remaining all other outputs are zeros. Remaining all other outputs are zeros. Fine. Now in this case OP4 is connected to where? IP6. So this input line is 1. Remaining all other inputs are zeros. Right? Okay. Now IP6 is 1. That means 6. Only this input is 1. Remaining other input lines are 0. Now since it is the encoder, you are getting code correspond to 6. 6 is nothing but what? 110. 6 is nothing but 110. Now forget about here internally whatever happening. Now just consider overall circuit input is 100, output you are getting 110. So whether it is binary to gray or gray to binary, now we have to decide. So let us verify. Okay, 100 I am considering. 100. Suppose let us consider that is the binary. Suppose. Then the corresponding gray code is what? We'll copy the MSB as it is. Whether binary to gray or gray to binary, first step is same. Copy the MSB as it is. After that, perform XOR operation among successive bits. 1 XOR 0 is 1. Then 0 XOR 0 is 0. Yeah, 1 XOR 0 is 1. Then 0 XOR 0 is 0. Yes. If you have considered the input 100 as the binary, the corresponding output 110, yes, exactly you are getting, that is your gray code. Okay, so that means here the given circuit is acting as binary to gray. That means option C is the correct one. Now some of you might be having, sir, whether it can be gray to binary or not. Okay, if you are having still doubt, you can verify, no problem. So whatever the input here, yes, same 100. If you treat 100, suppose if you treat as gray code, suppose, okay, 100 if you treat as gray code. Now let us verify what is the corresponding binary code, whether you are getting or not. See, as I told earlier, binary to gray or gray to binary, the MSB will be copying as it is. MSB we are copying as it is. So MSB is going to be 1. Then earlier binary to gray code, among the successive bits you are performing XOR. Whereas here, whatever the currently you got bit, that bit here you have to perform XOR with the next successive bit. XOR operation. 1 XOR 0 is what? 1. Then 1 XOR 0 is what? 1. Now this is your what? Binary code. Suppose if you have considered input as the gray, the corresponding binary, it should be in this example 111. But are we getting 111? No, we are getting 110. Right? So that's the reason here option A won't be correct. But if any of you verify the first 4 combinations regarding 3 bits or 4 bits, it will satisfy for binary to gray, it will satisfy for gray to binary. But whenever you are having MCQ, definitely one correct choice will be there. That is the reason, to avoid any silly mistakes, etc., especially for MCQ questions. So especially for this concept, I am telling, don't verify first 4 combination starting from 3 variables. Okay, you can verify with the help of remaining any one combination. Straight away you can decide whether really acting as binary to gray or gray to binary. In your free time, if you want to give a try with the help of remaining any of the combination, you can give a try. So definitely it will satisfy for binary to gray this overall circuit. Now with the help of this understanding regarding this question, in your free time you can draw the circuit for gray to binary also. Whatever the first 4 connections here you're having, exactly same. Regarding these 4 connections, okay, you can do the mapping in such a manner, gray to binary. Okay, say for example 100 means here OP4, so that line should be connected to where? IP7. That line should be connected to IP7. Like that, as per gray to binary, you can do the connections here, then overall circuit will become gray to binary code converter. So like that, whatever the codes, various codes that you have learned in the first chapter, like BCD code, XS3 code, gray code, similarly data representation like unsigned, signed magnitude, 1's complement, 2's complement, from any one form into any other form, if you want to convert with the help of decoder and encoder combination, we can do. That is the reason here, conclusion point, with the help of decoder and encoder, we can do various code conversions. See, this is the most important thing. With the help of whatever the quality questions while you are solving, definitely the main intention is you have to get the correct answer. But moreover that, with the help of that question, what learning point is there, what insight that you got, that is the most important. Because when you are preparing for competitive exams like GATE, so the basics are important and application of the basics are important and conclusion points are important. All these things, if you are learning while solving good number of quality questions, definitely your preparation is on par. Okay, right. Yeah. Next question. I hope all of you can do it. This is a simple question regarding mux. This is a simple question regarding mux. See, just read the question. The number of NOT gates, 2 input AND gates, 2 input OR gates required for implementing a 2-by-1 mux. See, I hope all of you know the standard equation of 2-by-1 mux. What is the standard equation of 2-by-1 mux? S bar I. Okay, I'm just writing here output of 2-by-1 mux, standard equation. Suppose I'm labeling output as Y. So since you're having 2-by-1 mux, how many selections you're having? Only one, right? If the selection line value is 0, then I0 will be connected to the output. If the selection value is 1, I1 will be connected to the output. That means 2 possible cases are there. So accordingly, logical are. Okay, logical are among those 2 combinations. Like if the selection value is 0, I0 is connected. If the selection value is 1, I1 will be connected to the output. Okay, now this is a standard equation of 2-by-1 mux. So for implementing this 2-by-1 mux, regarding logic gates, what are the basic gates like not AND gate, OR gate, NOT gate? Okay, how many such gates individually required? That is a question. See, just by observation, S bar. So that means here we require what? 1 NOT gate. We require 1 NOT gate. Right. So that means number of NOT gates required is 1. Number of NOT gates required is 1. So option B we can eliminate. Right. Coming to AND gates. S bar I0. That means here logical AND is there. And similarly S into I1, logical AND. That means we require 2 AND gates. Number of AND gates required is 2. Yes. So with the help of this understanding, we can eliminate D and A also. Okay. Obviously, one option is left over. That will be correct. Right. See, among these 2 terms, logical OR operation is there. For that, we require 1 OR gate. Yes. For that, we are using 1 OR gate. But order of the logic gates here mentioned accordingly, the respective option you have to choose. Okay. Here the first we are asking with respect to NOT gates. Number of NOT gates required is 1. Then AND gates required is 2. OR gate required is 1. So option C is the correct answer for this question. Right. Yeah. Next question. This is a question based on muxes. I am giving time for everyone. All of you try your level best. I am giving 1 minute time. I hope all of you can do it. This is a MSQ question. Either one option or more than one option can be correct. Yes, just observe here. Here in this question, you are having 2 muxes. In this question, you are having 2 muxes. Okay, right. Both are 2 by 1 muxes. Okay, just now only we have discussed 2 by 1 mux standard equation, S bar I naught plus S into I1. Okay, right. Now just observe with respect to this mux, selection is what? X1. Selection is X1. Now, you can use this equation. Now, accordingly what you are getting. Like X1 bar into I naught. I naught is what? 1. I naught is 1 plus X1 into I1. I1 in this case is what? 0. So 0 and anything is 0. And when you are adding 0 to something, the resultant answer will remain same. Okay, so orally what you are getting? Here you are getting X1 bar. That means output of first 2 by 1 mux, you are getting simply X1 bar. Okay, next. Here you are having once again 2 by 1 mux. Here in this case selection is X2. I naught equal to X1 bar, I1 equal to X1. Okay, now once again you can use standard equation and accordingly you can get the corresponding final expression. So here in this case F equal to selection is what? X2. X2 bar into I naught. I naught in this case is what? X1 bar plus selection is X2, then I1. I1 in this case is nothing but X1. So what you are getting here, X2 bar, X1 bar plus X2, X1. Okay, I'm just writing in the like numbering wise ascending order. Like I can rearrange this one as X1 bar into X2 bar plus X1 into X2. Like 1, 2 ascending order I kept. Okay, regular numbering. Now X1 bar, X2 bar plus X1, X2 is nothing but what? Exclusive NOR operation among the variables X1 and X2. Okay, so that option is there here in option A. Okay, in option A we are having. In option A that we are having. But the question is what? MSQ. So whenever you are having MSQ, even though you got one correct choice, but still you have to verify. You have to observe remaining 3 choices. If at all, if any correct choice is there, you have to mark that one also. Okay, right. So here OR gate X1 plus X2, it won't be correct. Here X1 excludes X2. No, it is not correct. Because here you are getting what? XNOR operation. XNOR is nothing but what? Complement of XOR. Yes, that is there in option D. Complement of XOR. So for this question, 2 correct choices are there. Option A, option D. In this way, the difference between MCQ and MSQ. For MCQ, the moment you are getting correct choice, no need to verify remaining choices. Provided whatever the process you followed for solving that question, you followed the process correctly and you haven't done even single silly mistake. Definitely your answer is going to be correct. But for MSQ, you have to verify each and every option whether it is really correct or not. So among the given 4 choices, just like MCQ, even for MSQ, only one correct option can be present, or even more than one, like 2 correct options, 3 correct options, or even 4 correct choices. All the 4 choices can be correct. So whichever correct choices are there, you have to mark accordingly. Then only you will be getting marks assigned for that particular question in the GATE exam, especially for MSQ. Okay, right. So for this question, 2 correct choices are there, option A and option D. Next question, once again mux based question, but earlier question is based on 2 by 1 mux. Now this question is based on 4 by 1 mux. This is one of the most interesting question. Definitely many of the students may get while solving this question, because just like the earlier question, this question is also of MSQ type. So while solving this question, you may get one of the choice, whatever you are getting as the correct, that might be matching, but definitely many of the students will get, while solving this question, they may choose wrong answer as the correct. One of the choice they may choose wrongly. The choice which is going to be wrong, they may treat as correct. Okay, many of the students may do silly mistake here. So I am giving chance for everyone. Try your level best. I am keeping timer also here. All of you can do it. Okay, intentionally I am giving 2 minutes time. Even though you can solve this question 1 minute, but still I am giving 2 minutes time. All of you can try to avoid the silly mistake. if you want to check your confidence and if you want to be perfect. Yeah, for this question, definitely many of the students in general, they may do silly mistake. Okay, accordingly they may choose one option among the four choices as the correct. Okay, or sometime they can choose more than one option also as the correct. But whether whatever the answer you got, whether it is correct or not, okay, I will be disclosing in some time. Okay, but definitely there are high chances, definitely many of the students may solve this question wrongly. Okay, because of misconception or conceptual understanding, there is the gap. Okay, because of that, generally some students may solve this question, like they may assume that their solving part is correct, but sometime whatever final answer they are choosing here, whether that might be correct or might be wrong. But many of the students may choose wrong answer as the correct. There are high chances are there. So that is the reason I kept this question, even though the part of the regarding solution part, it belongs to the second chapter. See, that is the beauty of our subject district circuit. Yesterday we already covered in detail good number of questions, variety of questions regarding first three chapters. Now in this session we are covering regarding remaining four chapters of district circuit subject. So with the help of these questions, wherever possibility is there, I have kept the link in such a manner. While solving these questions, you are getting recap of what are the questions or models, concepts that we have covered in the yesterday session. Okay, right. So that is the great learning. So when you are preparing for any subject, it's not that when you prepared one chapter only during that learning time, you are at logic high. After that, when you are preparing for next chapter, in the current chapter you are reached to logic high, but earlier chapter you reached to logic low. No, it should not be. It should be continuity should be there and link should be there. Whatever the points that you have learned in the earlier chapter, if any continuity is there in the upcoming chapter, always you have to correlate so that your overall preparation is going in the right manner. So definitely you can maximize your score in the GATE exam. Okay, right. Now just observe regarding mux. Okay, see, earlier I have discussed with respect to stand equation. Okay, for understanding purpose I have discussed, but once when you have studied regarding implementation of logic gates using muxes, right, with the help of that understanding, without writing the standard equation also, directly in one step you can get the final expression. Say for example, when you're having 2/n mux, here inputs you're having 1 and 0. See, you're having single selection line, that means that selection value can be 0 or selection value can be 1. When selection value is 0, I0 will be converted to the output. That means here you are getting output as 1 when selection value is 0. Okay, similarly when selection value is 1, I1 is getting at the output. In this case, I1 is nothing but 0. Very simple. With respect to one input logic gate, at the output column, you are getting 1 0. That combination you are getting for what? When you have given selection as 0, output you are getting 1. When you have given selection value is 1, output you are getting 0. That means here that selection value is nothing but input variable A, single input variable. Okay, so that variable A is getting complemented at the output. That means A bar. So in this case x1, accordingly x1 bar. That means this particular 2/n mux is behaving as NOT gate or inverter. That's all. NOT gate or inverter. Okay, right. Yeah. Now just observe regarding this particular mux, 4/n mux, here two selection lines are there, and those two selection lines here we have chosen as like variables, with the variables A and B. A and B we have chosen as selection line. Now here for this mux, input lines, if you observe, you are having in terms of ones and zeros. Okay, right. Now with respect to which two input logic gate, you are getting in the truth table at the output column, you are getting like this 1001. Yeah, Suganya, you can click on the bell icon. You can subscribe our YouTube channel and then click on the bell icon so that you will be getting all the instant notifications. Okay, whenever we are conducting either live session or even whatever the session we done in the recorded and then uploading in our YouTube channel, every notification you will be getting if you click on the bell icon after subscribing our YouTube channel. Okay, you won't miss any session whatever happening in our YouTube channel. Okay, I hope it is clear, Suganya. Right. Yeah, 1001, you are getting at the output of two input logic gate truth table. For which logic gate? 1001 you are getting for XNOR gate. Yes sir, XNOR gate. So here XNOR operation among the selection lines, that means here among A and B. So that means according you are getting A XNOR B. See, if you are having any doubt, okay, I will be discussing here so that you can easily correlate. Say for example, with respect to standard equation of 4/n mux, for the first stage, Y. So here since you are having two selection lines, so according you are having what? 4 combinations like 0 0, 0 1, 1 0, 1 1. Okay, so 0 0 case I0 is connected, right? So accordingly I am writing the respective combination like S1 bar, S0 bar, I0. 0 0 case I0 will be connected. Similarly 0 1 case I1 will be connected, but here I1 value is 0, I am not writing. Okay, but just for reference I am writing the standard equation for 4/n mux. Okay, fine. 0 1 case I1 will be connected like S1 bar, S0, I1. Then 1 0 case what? S1, S0 bar, 1 0 case I2 will be connected. Then 1 1 case I3 will be connected. So this is the standard equation for 4/n mux. No need to by heart anything. See, just like here, when you are having single selection line, when that value is 0, I0 is connected. When that value is 1, I1 is connected. Accordingly, you are writing expression exactly similar way. When you are having two selection lines, based on the combination of selection lines, accordingly respective input is connected. 0 0 case I0, 0 1 case I1, 1 0 case I2, 1 1 case I3. Just for understanding point of view, I have written the standard equation. But whenever you are having multiple muxes in the given circuit, that time you have to analyze or you have to get the simplified expression stage by stage, and then you have to proceed. While you are solving the question in the gate exam, no need to write the complete equation. Rather, whichever input values other than 0 are non-zero, very simple. Whichever inputs other than 0 are non-zero, that respect to input lines, with respect to that, the respective selection terms you have to consider. That's all. Why I told this point, reason is very simple. I1 0, that means the moment I1 0, this term is 0. Similarly, I2 is 0, this term is 0. 0 plus 0 is what? 0. And when you're adding 0 to this remaining term, whatever leftover term, you are getting resultant answer will remain same. That is the reason. Okay, I hope it is clear for everyone, right? Now with this understanding, now let us get the output expression of first stage marks. Okay, in this case selections are A and B, so accordingly A bar B bar into I naught value is what? 1. Okay, then second term is 0, third term also 0, because here I1 is 0, I2 is 0. Fine, right? And the last combination, last term, you are getting what? AB into I3 is what? 1. So now what you are getting? A bar B bar plus A is nothing but AX nor B. A bar B bar plus AB is nothing but AX nor B. Right? So I hope all of you understood. With the help of logical expression, whatever the expression you are getting, the same expression you are getting. Once if you have observed that for any marks, when you are having inputs in the combination of ones and zeros, so just observe with respect to the how many selections you are having with respect to logic gate. Okay, that means here 2 selections are there, that means 2 inputs you are considering. With respect to which 2 input logic gate, output column you are getting like this. That operation, logical operation, you have to perform among the selections or among the respective variables. That's all. Yes, very good, Suganya, very good. So here first stage we are getting AX nor B. Now once if you understood up to here, now after that here in this case second stage whatever you are having, once again same 4 by 1 marks, and just like here 2 selection lines, and whatever the 4 inputs here you are having 1001 exactly same. That means just now only we understood among these two selection lines XNOR operation, exactly similar way among these two selection lines XNOR operation you are getting as the output. Okay, now with this understanding, here final output that you are getting f of ABC equal to here one selection line is what? AX nor B. Another selection line you are having C. Yes. So that is there in option A. Yes, definitely option A is correct. There is no doubt here. Okay. So up to here, many of you got correctly. But this question is what? MSQ. This question is of MSQ. So the moment you are getting here, most of the students will be choosing here, and some students may choose any of the other wrong choice, like if they done any single mistake here. Then because of that they may choose any other wrong choice. Okay, but here because the question is MSQ, either one option or more than one option can be correct. Okay, as of now you have chosen option A. There is no doubt here, but now just by observing that expression or here AX nor B X nor C, definitely it won't be equal to ABC, so we can eliminate, and it won't be equal to AB plus C, definitely we can eliminate. There is no doubt. Up to here everyone are on track, I can say. There is no doubt. But now coming to option B, this is the most interesting tricky thing, whether option B is correct for this question or not. All of you think and answer. This is a very, very interesting point. Actually, this is a great learning point and important insight with respect to second chapter that I am covering with the help of this question in the 4th chapter with the help of mux based circuit. Here you are having XOR. Okay, whether it is correct or not. Don't hesitate. If your answer is correct, I will appreciate. If you are getting wrong answer, no problem. At least when I am discussing explanation part, through that, if any of you done mistake, at least you can learn from that mistake. See, the purpose of this session is what? We are highlighting, we are covering each and every important point, concept through the questions we are covering, and of course, variety of questions we are covering. And with the help of whatever the questions we are covering, these are the expected models for your coming GATE exam, and you are getting basics and application also, like with respect to your exam point of view, how to solve that question and how to understand the question, etc. Each and every point you are getting with the help of these live sessions. Okay, and not the least, whatever in general many of the students may have the misconception or may solve the question wrongly because of silly mistake, those areas also we are touching so that you people can overcome in your upcoming GATE exam. Okay, right. Many of the students in general may say that, okay, A x nor B x nor C will be equal to not this equation, they may say one more equation. Okay, yeah, so here I'm writing A x nor B x nor C. Okay, you can perform x nor among any two variables first and then with third variable. All these are equal only, there is no doubt. Okay, now tell me whether all these three are equivalent to this expression or not. Many of the students may say that all these expressions are equivalent to this one, but that is not correct. That is a twist. These are not equivalent to this one. It seems to be like that, but not. Okay, I am going to reveal why it is not equivalent to this expression. Because many of the students may think that any of these three equations are equivalent to, in fact, all these equations individually are equivalent to this expression. Because of that, they may ignore this choice. Okay, but actually, when whoever knows any of these equations are not equivalent to this one, damn sure they can choose this one as a correct. Okay, I am discussing the proof now. Okay, yeah, so A x nor B x nor C. See, very simple. Just like when you're having two variables like x1 x2, when you're having two variables x1 x2 among which you want to perform x nor, right? What is the expression? Both the variables complemented individually and then logical AND, then both the variables normal and then logical AND. After that, among those two terms you are performing logical OR, right? That is the basic definition regarding two input x nor gate, right, or two input x nor expression. Now with the help of this understanding, now let us write the expression here. So this is the first term, this is the second term, right? So in the first term, while you are writing the x nor expression expansion, so both the terms are getting, or both the, here this is the first variable, this is the second variable, like that you can treat. So the first term Ax nor B complement and the second variable also complement, right? So Ax nor B and then here C, right? Just like x exclusive nor y is nothing but x bar y bar plus x into y. X into y means both are normal. So accordingly you can write Ax nor B and then C. I hope it is clear up to this point. X bar y bar plus xy format. Now complement of x nor is what? XOR. Complement of x nor is XOR, right? Okay. Then here you are having x nor. X nor you can write as complement of XOR. Complement of XOR. Yes. Now just observe. This is looking in which form? X bar y plus xy bar. That means exclusive OR operation, right? So here the first variable and second variable, among which exclusive OR operation. Exclusive OR operation. Now regarding XOR operation, like when you are having any number of variables, either 3 variables, 4 variables, any number of variables, when you are performing among any 2 variables first and then with the third variable or whatever the remaining combination, after doing further simplification, it will match with XOR operation among all the variables directly. XOR operation among all the variables directly. Yes, very good, Saganya. Mention your name of the branch and currently you are studying which year BTech. Okay, just for reference you can mention. Yeah, so here you are getting XOR, right? So that means just observe here. Here A XOR B XOR C, this is nothing but what? A XOR B XOR C, right? So that means option B is also correct. Option B is also correct. So for this question, 2 correct choices are there. But in general, many of the students while solving this question, if they do any single silly mistake or any silly mistakes while solving the question, they may choose the wrong option as the correct, or maybe more than one wrong choice also they can choose, or whoever might have solved the question up to here correctly, but whoever having the misconception that any of these equations or all these equations are equivalent to this expression, because of that they may ignore this option. But here this option is also going to be correct. Okay, and here since we have discussed this point, I am giving one more note point, okay, just for reference. Yeah, so here with respect to, like say for example, when you're having 4 variables like A XOR B, then XOR with C XOR D, so this equation, whether it will match with this one or not, just confirm. So here these equations are not equivalent to this one. Now my question is whether this equation is equivalent to this one or not. Yes, in this case it is true. That is a twist. Because many of the students will apply this logic here. See, this logic here it is true. The reason is very simple. Whenever you are having even number of variables, that time if you are performing XOR among pair-wise, then like here 4 variables I am talking. Okay, here 2 variables and then 2 variables. Okay, then it will match. Okay, but here you are having 3 variables. That time when you are performing among 2 variables and then with third variable, that time it won't balance with this one. Rather surprisingly you are getting what? XOR. See, very simple. When you are doing, say for example, just focus this logic, in which case like this expression valid, in which case not valid. Very simple, very simple. When you are performing here among 2 bits, right? So accordingly, after doing one iteration like that, once again you are getting 2 bits, right? Then like that case when you are getting, definitely it will valid. Yes, very good, Saganya, excellent. Right. So when you're having here, when you're performing XOR here, and then here you not performed XOR, that means whatever the bit you are getting, with that bit you are performing XOR, right? In such case, that equation won't be valid for this one. Okay. So just for reference here I am putting, so what is the difference between this, any of these equations and this equation? Very simple. For reference I am putting here A XOR B XOR C is nothing but, in general XOR expression is what? Complement of XOR, that's all. Okay, complement of XOR. Now just observe. All these equations are equivalent to XOR. So when you are saying those are equivalent to XOR, at that time it won't be equivalent to XOR. Among all the variables, XOR operation directly. That is the difference between these expressions and this expression. Okay, in general, you know, like with respect to 2 variables or more than that, okay, if you want to write XOR, you can easily write, okay, by doing the analysis. But coming to the XOR, if you are having 3 variables, directly you cannot write. But you can follow what, like this logic you can follow. First write the XOR expression and then you can put complement. Otherwise, whatever the conclusion points we have discussed, like even number of ones or odd number of ones with respect to which case you are getting output 1, accordingly you can write the respective min terms, accordingly also you can write. Okay, that is another logic. That concepts we already covered in the last class. Okay, right. So I hope all of you felt this is one of the very, very interesting question. It is the, even though students know the concept how to solve the question, but still whenever the question is MSQ, definitely there is a suspense and surprise, because you don't know really how many correct choices are there. Unless otherwise you are marking whichever correct options are there, you won't get marks assigned for that question. So that is the twist is there in the GATE exam. So always have the alert, especially for MSQ question. Okay, whichever questions you can solve in less time, definitely you can touch in the first round. But whichever questions like this typical or little bit twist is there, keep hold for second round or third round. Definitely you can try, but unless otherwise you are marking all the correct options. Because of that, even though you solved partially, some options are correct, but unless otherwise you are marking all the correct options, you won't get marks assigned for that question, right? Okay. Yeah. Now the next question is a dead easy question. I hope all of you can answer. You are having 8/1 marks. Okay, so I'm giving 1 minute time, no hurry. Try to observe the circuit and then observe the choices. From there you can choose the correct option. Yeah, we already discussed one important note point earlier, okay, regarding marks based questions. Exactly same point if you apply, definitely can answer. Very simple, just have observation. Whenever you're having any marks, okay, just have observation regarding the input lines. Okay, here you're having, when you're having in terms of ones and zeros, just focus with respect to which logic gate output column you're getting like that. That's all. That logical expression will be that you will apply among the variables or among the selections here. Okay, yes, very good, very good, very good, Suganya, very good. Other student also, just mention your name so that I will pronounce accordingly. Okay, yeah. So for this question, you just observe only the last combination you are getting 0. That means very simple, like when you have given 111, when you have given selections as 111, that time I7 will be connected to the output. That means for 111, when you are having 111, that time you are getting 0. That means very simple. AND gate means what? When all the inputs are 1, output you are getting 1. Exactly opposite. That is for NAND gate. So that means NAND gate, when all the inputs are 1, you are getting 0. For remaining all the cases, you are getting output as 1. So that means accordingly you are getting 3 input NAND gate. That's all. That's all. That is the beauty of mux. That is the beauty of the mux. With the help of single mux, as we have discussed regarding mux is a universal element. Yes, you can try to understand that point with the help of any of the questions whatever we discussed, even with the help of this question also. You just observe number of variables of this function is 3 and number of selections we have chosen 3. That time with the help of single mux, you can get the respect to whatever the Boolean function you want to get it. That's all. Okay, and similarly, when they are giving, suppose for this mux, you may be having 2 variety of questions. One variety, they can give the output expression, they can give the selection, they can ask input value. Or another variety, they are giving input value, selection, and they are asking output expression. For solving these questions, whatever the logic just now we discussed, exactly with the help of that logic, you can easily solve the question. For whichever questions you cannot solve with the help of that logic, then you can use a standard equation and then you can do the simplification. Even standard equation also, you no need to write for all the combinations, but whichever combinations you are having, like non-zero combination, like say for example when you're having 4 by 1 mux, earlier we already touched that point. Okay, 1001 case like that. Similarly, if you apply that logic here, because 7 inputs are having non-zero, because of that when you write 7 terms, after that if you do simplification, surprisingly whatever the final expression you are getting, that is nothing but ABC whole bar only. Okay, but it will take lengthy process. But for whichever like lengthy questions, if you know these basics, definitely you can solve the question in less time. Okay, right. Yeah. Now the next question, you are having two statements like statement A and statement R. Now you are having 4 choices. So all of you can read the statements and accordingly you can choose among the 4 choices which one is correct. I'm giving 1 minute time. All of you can read it. Read and then give it a try. Yeah, just observe here. Regarding first statement, you are having 64 input mux. 64 input mux or 64 by 1 mux, both are one the same, right? Whatever the mux size, always the number of output lines are equal to 1. Okay, so 64 by 1 mux or 64 input mux can be built using 8 input mux or 8 by 1 muxes. Okay, whether it is correct or not, first let us give it a try. So say for example, here we require 64 input line mux. Okay, that is our objective. But in order to implement that mux, we are allowed to use 8 input mux. Okay, so that means at the input stage or first stage, we require 8 by 1 muxes. See, at the first stage, if you considered 8 by 1 muxes, so with the help of each mux, you are getting 8 lines. Like that, 8 into 8 is what? 64. Okay, so that means at the first stage, from every mux you are getting single line. That means 8 lines you are having. Okay, 8 lines you are having. Now, for overall 64 by 1 mux, number of output lines required is 1. But after the first stage, you are getting 8 lines. Okay, but your final objective is to get 1 line, right? So that means here you are allowed to use 8 input mux. So you can consider 8 by 8, 1. So that means here you require 8. At first stage you require 8 and at second stage you require 1. That means together you require 9 8 by 1 muxes. We require 9 8 by 1 muxes. But here they mentioned by using 8 input mux or 8 by 1 mux. No, not possible. We require total 9. See, 8 muxes required at the first stage. But overall, in order to get 64 by 1 mux, at second step we require 1 more mux. So together 8 plus 1 is 9. Okay, because of that, statement A is wrong. Statement A is wrong. Yeah, the moment statement A is wrong, you just observe A is false. That is there in only one choice. Damn sure you can choose option D. Yes, very good, Suganya. Excellent. See, the moment if option A is true, suppose, then you have to verify regarding statement R also. after that, suppose if statement R is true, suppose, then you have to verify. Then you have to verify regarding here and regarding here also. Okay. Right? Suppose if both are true, A and the moment A is true, then you have to verify R. Suppose if this is true, then you have to verify statement like option A. Suppose if this is wrong, then you have to verify option B. Okay. But here luckily the statement A is wrong. So then you don't need to worry about option A, option B. Then just observe here, A is false, that is there in only one choice. Definitely option D is correct. But let us verify regarding this part whether it is true or not. Regarding this part whether it is true or not. Yeah. So let us read the statement. Any 6 variable function, that means you are having a Boolean function which consists of 6 variables. Okay, right. That 6 variable function can always be implemented by a single mux, with 6 selection lines. Yes, this statement is true. Just now only we have discussed. With the help of 3, just observe. Regarding this Boolean function, it consists of what? How many variables? 3 input variables, and number of selections we have chosen 3. That means with the help of single mux, we are able to provide, we are going to implement 3 variable Boolean function if you have chosen 3 selection line mux. Like that, if you want to implement 6 variable Boolean function, you require 6 selection lines for that particular mux. Then with the help of single mux, you can implement that Boolean function. Yes, that statement is true. So that means finally option D is going to be the correct answer for this question. Right? Yes. So far, whatever we have discussed in this particular session, we have discussed the questions regarding the 4th chapter, that is combination circuits. Okay. We have discussed all the important models. Through the questions, we have covered all the important concepts and most important concepts for your coming GATE exam, and of course variety of questions also we covered regarding 4th chapter. Now we are going to discuss the questions regarding 5th chapter, that is sequence circuits. In general, many of the students will face little bit challenge in this particular chapter. Now whatever the questions I am going to cover in this particular session regarding this chapter, so whoever know already the basics wise clear regarding this chapter, definitely try your level best to get the correct answer. But even if you are solving the question wrongly, don't hesitate. When I'm discussing the explanation, with the help of that, definitely you can get confidence and you can get the knowledge wise crystal clear regarding this particular concept, of course regarding question solving also. Okay, right. Yeah. So this is a question based on flip-flop. Generally in every chapter, whatever the questions order I used to put, in such a manner it will go in the sequence. But in this particular chapter, even though title is sequence circuit, but here just I want to give the glimpse in such a manner, I kept regarding sequence circuits, whatever the concepts you are having, I kept the questions like random manner, intentionally I kept, so that you are getting overall. See, when you are preparing for any subject, okay, you have to prepare chapter by chapter, like that subject by subject you have to complete. That's true. But when you are going when you are going for actual GATE exam, whatever the branch you may belong to, EC, CS, electrical, instrumentation, whatever the subjects you are having with respect to GATE exam, all the subjects you have to treat like single branch, your own branch, right? So you have to consider like that. To reach to that level, you require a lot of patience and practice. Then only you can visualize or treat all the subjects together like one branch subject. Okay, so like that feel I want to create. That is the reason intentionally I kept whatever the questions I have kept in this particular chapter, intentionally order wise I kept some random manner intentionally. But definitely with the help of each and every question, definitely you will be getting a great learning regarding this particular chapter. Definitely you'll be getting great confidence with the help of whatever the questions I'm covering here. Okay, except this chapter, remaining all the chapters, like starting from first chapter to the last chapter, except this chapter, every chapter I kept all the questions with respect to our lecture flow exactly in the same sequence. Only here I kept little twist, so that when that random nature is there, so how you people are actually responding, so that I want to check. So that is the reason intentionally I kept in this particular chapter order of the questions some random manner. Okay, right. Yeah. So here, let us read the question. You are having like inverter or NOT gate that is placed between the J and K inputs. J and K inputs of a JK flip-flop. Then the resultant flip-flop become what? See, for solving some of the questions, whether the name of the circuit or in the circuit, whether you are having latch or flip-flop, resistor or counter, whatever it may be. For solving some of the sequence circuits, one method of solving is whatever possible. Okay. See, for solving sequence circuits, in general, you're having 2 or 3 methods. Based on the question, whatever the method is applicable, accordingly you can apply. That's all. If you know the standard equation of like SR latch, D latch, JK latch, T latch, exactly respective equations will valid for flip-flop. Only thing, latch means we are operating at the level, whereas flip-flop means we are operating at the edge, either positive edge or negative edge. But whatever the standard equations are there, 4 equations, if you remember, with the help of that, some of the questions of sequence circuits you can easily solve. Okay, right. So that approach I am discussing now. So here, first of all, since the context of the question is JK flip-flop, first of all, write the characteristic equation of JK flip-flop. Q of T plus 1 equal to JQ bar plus K bar Q. This is the characteristic equation of JK flip-flop. JQ bar plus K bar Q. Right? Yes, very good, Suganya. Very good. Now, in this question, what they mentioned, between J and K inputs, one NOT gate is placed or inverter is placed. Okay, so that means, so I am considering like this. As per the context of the question, I am assuming let J equal to X, suppose. Let J equal to X, then K will be what? X bar. Because between J and K inputs, one NOT gate is placed. Okay, for the timing I labeled J as X, that means K is going to be X bar. So the moment K value is X bar, what is K bar? X bar whole bar, that is nothing but X. X bar whole bar, that is nothing but X. Now, just substitute in place of J and in place of K bar, here you are having X, you can substitute here. Now, this equation become Q of T plus 1 equal to Q of T plus 1 equal to, right. Now, J value is what? X. Then Q bar plus K bar is nothing but X, then Q of T. Now, just observe this equation. We can take X as common. From these two, we can take X as common. Then you are getting Q bar plus Q. Q bar plus Q. So Q bar plus Q is nothing but what? 1. So that means finally you are getting X. So what is your observation? The final simplified characteristic equation, you are getting Q of T plus 1 equal to X. It is matching with D flip-flop, provided if X equal to D. That's all. So that means here, in this case, option B is the correct answer for this question. Okay, just for reference, I am writing Q of T plus 1 equal to D. This is the characteristic equation of D flip-flop. So if X equal to D, then it is D flip-flop. Okay. Right? So option B is the correct answer for this question. Suppose in the question if they mention like J and K inputs are tied together, then JK flip-flop will become which flip-flop? I hope all of you can answer this question correctly. If J and K inputs are tied together, that means J and K are same. Then JK flip-flop will become T flip-flop. Okay, that you might have learned. See, regarding SR flip-flop, regarding JK flip-flop, the respective two inputs are complement each other, then SR flip-flop will become D flip-flop. Similarly, JK flip-flop will become D flip-flop. Okay, this is one of the important note point. Okay, whoever already know, that is a, it's good, but whoever don't know, at least with the help of this approach, you can solve this kind of question. Okay, right. Now, this is the question based on counters. This is a very interesting question. I'm giving time for everyone. All of you can give it a try. Yeah, still I am giving the time. All of you can give it a try. Yeah, Suganya, you can cross check once. There is a little twist is there in this question. Your answer is almost near to the correct answer. So just cross check once. Yeah, here just observe. What is mentioned? Here you are having a counter. Okay, it has to count from 0 to 1024. 0 to 1024 it has to count. That means total how many values are there? Total it has to count 1025 values. 0 to 1024, that means 1025 unique values it has to count. That means here in this case 10 flip-flops are not sufficient. 10 flip-flops are not sufficient. See, generally many students will answer this question as 10. That is the reason intentionally I kept here. Okay, see, very simple. Like if you think that 10 bits are sufficient, 10 bits if you are having, suppose example, then you are getting number of combinations are 2 power 10 only. But since you are starting from 0, maximum value will be 2 power 10 minus 1. So 2 power 10 is nothing but what? 1024. From there minus 1. That means 1023. So that is the twist here. So 0 to 1023. That means in order to represent any of the values, 10 bits are sufficient. But here intentionally I kept the twist. Instead of mentioning 1023, I kept here 1024. But 0 to 1024 means 1025 values. Okay. So 1024 you cannot represent with the help of 10 bit. You require one more extra bit. Yes, very good, Suganya. Very good. So in this case, we require, if you are having 11 bits, okay. So in this case, we require 11 bits. So since you require 11 bits, obviously 11 flip-flops you require. That's all. 11 flip-flops. So answer for this question is 11. The question solving is easy, but generally in hurry, we know that 2 power 10 is nothing but 1024. Because of that, 10 is the answer. Okay, even the NIT question, there won't be native marking in the GATE exam, but even the basic question, dead easy question, if at all if they're giving, but don't be in hurry. Even though you can solve the question, but once again cross check in the GATE exam I'm talking. Currently, I'm appreciating whoever marking this question as 10, I'm appreciating only, don't hesitate, because you are learning and try to correcting yourself wherever in general students will do silly mistake, right? That is the opportunity that you are learning or that you are getting with the help of this live session, right? Yeah. Fine. Next question. Here you are having one T flip-flop, and then here like OR gate is there, like this. See, this, like as I mentioned earlier, like the first question of this chapter, if you observe, one sentence was there, either like this sentences, or in some question they will be giving one flip-flop or latch, and with the help of some logic gate, with the help of some feedback mechanism like this, they can ask what is the overall circuit, etc. So for solving any of the questions, the method of solving is same. That is, whatever the method here just now we discussed, exactly similar method you can follow. Okay, what you have to do? First of all, you have to write the characteristic equation of given flip-flop or latch. Okay, here in this case you are having T flip-flop. So T flip-flop characteristic equation is what? T flip-flop characteristic equation, Q of T plus 1 equal to J Q bar plus K bar Q. Sorry, T flip-flop, no? So directly you can write TXRQ. Yeah. So just observe here. I already touched that point earlier. So see, this is the JK flip-flop characteristic equation. If J and K are same, that means TQ bar plus T bar Q. That is nothing but XOR operation. So accordingly you are getting TXRQ. Right? This is the first thing. So here you are having given flip-flop is T. So accordingly we have written the characteristic equation of the given flip-flop. That is T flip-flop characteristic equation is TXRQ. Okay. Now in this question, T is what? Just observe. In this question, T is nothing but output of this OR gate. OR gate is having two inputs. One input is what? Q. Another input is what? Q bar. One input is Q. Another input is Q bar. Yeah, for the timing I'm writing like Q of T, no problem. Q of T, then Q of T bar. Right. Now, when you're performing logical OR among these two, like just like X plus X bar is nothing but what? 1. X plus X bar is nothing but what? 1. So that means you got T value 1. Now you can substitute that T value here. T value you are getting 1. So 1 XOR Q. 1 XOR Q, that is nothing but Q bar. 1 XOR Q is nothing but Q bar. Now, what you got? Very simple. The final characteristic equation, you got Q of T plus 1 equal to Q of T bar. When it will happen? See, because it is a flip-flop, you are having here this symbol, right? This indication what? Edge. And here there is no bubble, that means it is a positive edge. Okay. And here clock signal given. So whenever clock signal changes from 0 to 1, because it is a positive edge triggering. For every clock signal that changes from 0 to 1, then only it will happen. Yes, very good, Suganya. Excellent. Okay. So here very simple, like if you draw the waveform, what will happen? Like clock signal I am considering. Okay. Now this is the clock signal we are having, right? 0 to 1 transitions I am focusing. Now corresponding output waveform. Initially you can assume 0. Then here you are getting first time positive edge, then second time positive edge, then third time positive edge, like that. Okay. right? So now here you can observe, like when you are getting first time positive edge, now q of t plus 1 equal to what? Complement of present state. So now 0 will become what? 1. 0 will become 1. So that will be there, till you are giving second time positive edge. Okay, the moment you are giving second time positive edge, once again you are getting complement. So now complement of 1 is what? 0. Now third time positive edge, once again it is getting complement. Like this the pattern will continue. Now overall if you observe, like whatever the pattern 1 0, like that pattern will repeat. So in the output waveform you are getting two possible values, like 1 and 0, 1 and 0, like that. That means this particular whatever the circuit you're having, you are getting only two possible values, like 1 0 or 0 and 1, whatever it may be. That means it is nothing but mod 2. Okay, so accordingly you can say option A is the correct one, mod 2 counter. That's all. So here conclusion point is very simple. I hope all of you learned 3-bit binary counter, up counter, down counter, whatever. That time 3 bits are there or 3 flip-flops are there. Accordingly you are getting 8 possible states. With the help of ripple counter I am talking, then it is nothing but mod 8 counter. But now in that circuit also if you observe, for every flip-flop t value is 1. And here exactly same thing you are getting. Okay, see, just observe t value 1 only, but instead of giving directly t value 1, here I kept one OR gate and then I have made the connections, and surprisingly you are getting the same thing. So these are the great insights, whatever the concepts you learned in the DC circuit subject. Now that concepts and principles that you are learning with the help of the questions, this is the second, another art or another approach to learn the concepts, to get the basics clear. With the help of questions you are learning the concepts. Okay, so when you are preparing, especially near to the gate exam, when you want to do the revision or practice, so you should not do the way that you have done very long back, because that time you might have done systematically. That approach is required initially when you are learning, when you are having long span. But when exam time is getting closer, so that time, because time is limited, you have to learn all the concepts, principles, basics, everything through the selective questions. By practicing them, you have to try to recap all the concepts, everything, whatever you have learned. Okay, so that wherever required, see, entire concept I have discussed in detail for understanding point of view, but once if you know all these basic points clearly when you're having, then definitely you can solve this question without using pen and paper. Okay, without using pen and paper. Yeah, here very simple, like whatever the output line here you're having, right? This output line, like for every positive edge of the clock signal, it is getting complemented. Suppose initially if you are having 0, after you are giving one time positive, first time positive edge of the clock signal, 0 become 1, second time positive edge, 1 become 0, like that. Here you are having single output line is there, and you are giving continuously this periodic waveform, square waveform. So output is staying at 0 or 1, like that. Only two possible values. That means the counter mod value is going to be 2. Okay, it is producing only two possible states, 0 and 1, or 1 and 0, whatever it may be. Yeah, next question. I hope all of you can do it. For reading the question it may take time, but after that you can easily solve this question. Okay, I am giving 2 minutes time, all of you can do it. Yes, very good, Suganya. Very good. So in this question, you're having 8-bit ripple counter, 8-bit ripple counter. Okay, and you're having similarly 8-bit synchronous counter. See, when you're having ripple counter, it is not a synchronous, or in other words, we can say asynchronous counter. Okay, so very simple. Here you're having asynchronous counter and synchronous counter, and both are having 8 bits each. Okay, so that means in both the circuits you're having 8 flip-flops. Fine. Now, and in this question it is clearly mentioned all the flip-flops are having a propagation delay of 10 nanoseconds. Each flip-flop is having propagation delay of 10 nanoseconds. Okay, now if the worst case delay or maximum propagation delay all are one the same. Okay, in the ripple counter it is mentioned as R, and in the synchronous counter it is mentioned as S. Now respective values we have to choose. Very simple. When you are having synchronous counter, that means for every flip-flop clock signal is same. The moment you have given, just like here, say for example in this particular circuit, one flip-flop is there, clock signal you have given, right? Now like that multiple flip-flops are there. For every flip-flop, the same clock signal if you have given, that means after you are giving respect to positive edge or respect to negative edge, whatever. In this case, it is positive edge mentioned. Similarly, you can consider negative edge, no problem. The moment you have given respect to positive edge for every flip-flop, based on the input, here respect to output, whatever it has to get based on the characteristic equation, it will update. If the flip-flop is ideal, immediately you are getting the moment you are giving corresponding positive edge. But just like logic gate, here flip-flop is having delay. That means each and every flip-flop can produce the output after whatever the individual one flip-flop delay. That's all. That is the meaning of synchronous. Synchronous means every flip-flop is having same clock signal. Say for example, first flip-flop is producing the respect to output 1 after suppose 10 nanoseconds. That means second flip-flop also, third flip-flop also, fourth flip-flop also, whatever the final output based on the characteristic equation, it is getting updated after the same delay. Okay, so with this understanding, S value is going to be whatever the individually one flip-flop delay. That's all. So S value is 10 nanosecond. That is there in option C. That means here option B we can eliminate. Now coming to A and D, we have to decide. Very simple. In the ripple counter, as we mentioned, ripple counter is nothing but binary counter, right? There you are having multiple flip-flops. Okay, and only for the first flip-flop external we are giving clock signal only, but for all other flip-flops, right, output of one step we used to give as the clock signal for next. That means when you are having 8 flip-flops, okay, extreme case, like with the help of every flip-flop you are getting one delay. Like that extreme case, 8 flip-flops are there, that means 8 stages delay. So that means here 8 into 10. Okay, since 8-bit, 8 flip-flops we are using, 8 into 10 nanosecond. That means 80 nanosecond. Option D is the correct one. So obviously it is not correct. Okay, so just for reference I am putting here. So in the synchronous counter, here S is there as per the question here S. So I am considering propagation delay of the flip-flop. That's all. Whereas for ripple counter, how many bits you are having, that many stages are there. So n into propagation delay of the flip-flop. Right? Okay. So in this case, propagation of the flip-flop is given as 10 nanosecond. Here n value is 8. So 8 into 10, that is nothing but 80 nanosecond. Yeah. So R value is 80, S value is 10. That means option C and option D are correct. Option C and option D are correct. Yeah. Next question. So in this question it is mentioned that binary down counter. Okay, this wording is important. Okay, in general when they are mentioning binary counter, you can treat as up counter, no problem. But whenever clearly if they mention down counter, you have to consider exactly. Okay, and here in this particular counter you are having 10 flip-flops and initial value given like this. You are having 000, then 000, then 1100. Total 10 bits are there. Okay, total 10 bits are there. Initially what you are having, very simple. Regarding the least 4 bits, you are having 1100, and remaining all other higher order bits you are having zeros. Okay, fine. Now, what is the question? The value of the counter state as after applying value of the counter state. Okay, you can ignore this word, no problem. After applying value of the counter after applying 2060 clock pulses. After applying 2060 clock pulses. See, very simple. First of all, whenever you are getting such kind of questions, first of all, for the given counter, given sequence circuit, what is the mod value? That you have to find out. Once if you get, then after that you can perform modular division. That's all. Here 10 flip-flops are there. Okay, so when you're having 10 flip-flops, we already touched that point. When you're having 10 bits or 10 flip-flops, okay, regarding ripple counter or binary counter, right? So, like if it is up counter 0 to 1023, if it is a down counter 1023 to 0, whether it is forward or reverse, whatever it may be, with the help of 10 bits, you are getting 1024 values, correct? Now, with this understanding, here 10 bits or 10 flip-flops you are having in that particular binary counter. So that means first and foremost observation, the given counter is nothing but mod 1024 counter. I hope all of you understood how we are able to get this mod number. Okay, right? Yeah. Now, once if you understood with the help of one circuit where you are having 10 flip-flops, right? You are getting 1024 unique values or 1024 unique states, I mean to say. Now, the question is what? After applying 2060 clock pulses, what is the state? Yeah, hi Sumedha. So here you have to perform modular division operation. Very simple. Modular division operation. So first and foremost, we understood that the given counter is having mod value 1024, and since they're asking with respect to 2060 clock pulses, you have to perform modular division. That's all. Okay. Yes, very good, Suganya. Very good. So here in this case, 2 into 1024 is nothing but what? 2048. So you're getting remainder as what? 12. So very simple. After applying 2060 clock pulses, whatever the state that you are getting with the help of given circuit, exactly same state you are going to get even just after applying 12 clock pulses. That is the reason we are performing modular division. Very simple. Forget about this big value. Let us consider that mod 5 counter. Suppose mod 5 counter means it is producing 5 unique states because it is a binary counter, and that too, let us consider if it is up counter means 0 to 4, down counter means what? 4 down to 0. 0 to 4 or 4 down to 0, 5 unique states are there. Now, whatever may be the number here they may consider, whatever may be the number they may give, when you perform the division operation with 5, any integer, when you are performing division with 5, what are the possible remainders you are getting? In general, any integer number, if you divide with 5, what are the possible remainders you may get? 0 to 4, that's all. That means if you are getting 0, suppose whatever the initial state you are having, exactly same state. Okay, if you are getting 1, after applying first clock pulse, what is the state? Exactly same state, like that. After that, what is happening? Once again, 0 to 4, 0 to 4, 0 to 4. Okay, like that, here also we are applying. Just like when you are converting decimal number into base 5, then that time you are performing repeated division with 5. Remainders you are getting what? 0 to 4 only. Exactly same concept you can apply here. Okay, right. Now, since it is a down counter, and here initial value, if you observe, like whatever the state initial value you are having, that number when you convert into decimal, 1100 is nothing but what? 12. Okay, so whatever the given number was there, whatever the given number you are having, Yeah, 6 zeros and then 1100. 1100. So this is the binary number. So when you convert in decimal, you are getting what? 12. So since it is the down counter and you have to apply 12 clock pulses, so that means this value decrement by 12. So from there, what you are getting? 0. From there, you are getting 0. So here 0 means what? All the bits are 0. That's all. All the bits zeros you are having in option C. Option C. After that, what is happening? Suppose example, somehow that you got remainder as 13. That means after applying 12th clock pulse, you got 0. After that, next clock pulse, if you apply, the counter value reaching to the maximum. Maximum means all the bits will become 1. Like that, if you have to apply further clock pulses, then from the max value, counter value will get decrement like that. Because the here name of the counter is down counter. But if the counter is up counter, for every clock pulse, the value will get increment by 1. After reaching to maximum, then it will come to the original state. All the bits are zeros. Okay. Yeah, thank you, Novita, for sharing your experience. You have attended last year my Gate Score Booster sessions regarding communication, and currently you are in IISc Bangalore. Very good. Congratulations. And sharing your experience in the live session, in the comment section, in the chat. I am very happy. It is a great motivation for other students also, whoever attending the session live and whoever watching this session later in the record also. Yes. Yeah. Yeah. Next question. Yeah, even other students also saying congratulations. So I'm appreciating all other students who are attending live. Okay. Yeah. And appreciating, congratulating Nobita. Yeah. All of you can give a try. This is a question based on shift register. Okay. I'm giving time for everyone. Okay. So intentionally, I'm giving more time, even though you can solve this question less time. Okay. If you want, you can take little break, no problem. After that, we'll continue. Yeah, very good, Suganya. Excellent. Excellent. So in this question, you are having the shift register, right? And it is mentioned right shift register. That means for every clock pulse, the shifting operation is taking place towards right hand side bit by bit. Okay. Now here the question is, after applying 3 clock cycles, what is the content of the shift register? The content of the shift register after applying 3 clock pulses. Initially you are having 0110. Of course, here also it is there clearly. You have to apply 3 clock pulses. After that, what is the content of the shift register? See, with the help of this question, you are getting second method. With the help of this method, some of the questions of sequence circuit that you can solve. Okay, so that is nothing but tabular form method. That's all. Okay, so here the first column you will be having clock pulse. Here the first column you will be having clock pulse, and second column in this case serial input. Serial input is there, right? That we have to consider. After that, what are the 4 output lines you are having, that we will consider. Okay, so here regarding clock signal, you can assume it is a positive edge, or even if you want you can consider negative edge, no problem, whenever not mentioned in the block diagram. Okay, for the timing I am assuming respective positive edge of the clock signal. Similarly, if you want you can consider negative edge, no problem. Okay, final answer will remain same. Now here in this case serial input, that is nothing but output of this XOR gate. For the timing I am labeling these 4 outputs like QA, QB, QC, QD, suppose. Okay, QA, QB, QC, QD. That means the least 2 bits or least 2 variables among which you have to perform XOR. So that means QC XOR QD. Right? Okay. Now initially they have given 0110. Right? Now before applying first time positive edge, initial state was 0110. Now all of you tell me, initially when you are having this state, here you are having XOR gate. In order to get this serial input, whether we have to apply first time positive edge of the clock signal, or before applying only the serial input is available. Here this XOR gate is what? XOR gate is a part of combination circuit, right? The moment you are having input combination, here output you will be getting. That means you don't need to apply any clock signal, right? So here in this case, so among these 2 you have to perform XOR. That one you are getting as a serial input, right? Okay, now in this case 1 XOR 0 is what? 1. 1 XOR 0 is 1. That 1 is available before you are applying first time positive edge of the clock signal, right? Okay, now you are applying first time positive edge. Now the shifting operation is taking place towards right hand side. That means serial input will come here, then this bit will come here, this bit will come here, like that. That means in very simple you can say that these 4 bits are getting right shift by 1 bit. That's all. That means here you are getting 1011. Yes, 101. Now here just observe QC value, QD value is what? 1. 1 XOR 1 is what? 0. That is available before you are applying second time positive. This is the most important note point that you have to keep as a note while you are solving the question by using tabular form. I am repeating once again. After you are applying respective positive edge or respective negative edge, the respective operation, shifting or counter operation, whatever, that will happen. Now, whenever you are having any combination circuit or logic gates like this, that output is getting updated before you are applying next corresponding positive edge or corresponding negative edge. Fine. Now, after applying second time positive edge, here these 4 bits are getting right shift. Okay. So in this case, you are getting 0 1 0 1. 0 1 0, right? Okay, now in this case 0 XOR 1 is what? 1. Now third time positive the clock pulse we are applying. Now you are getting 1 0 1 0, 1 0 1 0, right? Okay, now the question is, after applying 3 clock pulses, or after applying third time positive edge or third time negative edge, whatever, so then final state we are getting 1 0 1 0. That is there in option D. Option D is the correct answer for this question. Option D is the correct answer for this question. Yeah. So this is the second method. With the help of this tabular form method, whichever question is possible for you to solve, accordingly you can apply. See, I'm not telling that whatever the methods I'm discussing regarding sequence circuit, every method is possible for every question. No, no. Maybe sometime for few questions, maybe both the methods may be applicable. But in general, for selective questions, first method is applicable. Selective questions, second method is applicable. But whatever the methods in general is, you can apply for most of the questions that we are covering with the help of this session. Damn sure with the help of whatever the procedures you have learned or learning currently, definitely with the help of that, you can perform well regarding the questions of sequence circuit in your GATE exam. Okay, right. With this understanding, now see the beauty of the next question. The next question you're having here T flip-flop, and then here you're having logic gates. All the logic gates are NOR gates. Okay, and now the overall circuit you have to identify. That will be one of the flip-flop. Actually, this model we covered, if you remember, the first question also we covered, and after the third question also we covered with respect to this chapter, and now we are discussing one more question currently. So just observe this part of circuit from your logic gates. Whoever studied logic gates chapter thoroughly, you might have seen this diagram somewhere in the logic gates chapter. If you can recall, then definitely you can solve this question just like that. But whoever cannot recall, they may face little difficulty in order to get what is the T value. Means by solving regular procedure, it may take time. After that, they may get correct. Some students still might be struggling. But whoever know, just try to guess what is this circuit. Just try to guess. Whatever here 4 NOR gates you are having, this whole configuration is nothing but which logic gate? All of you give a try. Regarding this particular 4 NOR gates configuration is nothing but which logic gate? Yeah. See, this whole configuration, whatever you're having, that is nothing but XNOR gate. XNOR gate. See, XNOR gate implementation using 2 input NOR gates that you might have studied, right? 4 NOR gates required. Yes, exactly that configuration only here I kept. Okay, right. So here in this case, whatever this whole configuration you're having, that is nothing but XNOR gate. Okay, so first of all, I'm writing characteristic equation of T flip-flop, that is Q of T plus 1 equal to T XOR Q. Now, in this case, this whole configuration is nothing but XNOR operation. Okay, XNOR operation among 2 inputs. What are the 2 inputs? Here, one input is X bar. One input is X bar. Right. Another input is what? Another input is what? Q. See, for whole this logic circuit, whatever you are having, right? You are having 2 inputs. One input is X bar, another input is Q. Among those two variables, you are performing XNOR. Because this whole configuration is nothing but XNOR. In your free time, whoever don't know this circuit is nothing but XNOR, you can give a try. Definitely you are getting XNOR only. Okay. So X bar exclusion or Q of T, then XOR with Q of T. Now, regarding this one, we already discussed in yesterday class. Whenever you're having 2 variables regarding XNOR, regarding XOR. Okay. So here one variable normal, other variable is complement. Like that, if you're having among the normal variables, opposite function you're getting. Since XNOR is there here, so XOR will come. Suppose if XOR is there, XNOR will come. But if both the variables are complement version, then among the normal variables, exactly same operation. If XNOR is there, XOR is there, XOR. You can give a try in your free time, whoever don't know this logics. Okay. It will applicable for 2 input. Okay. Right. Now, up to here, you're having exclusive OR and then XOR with Q. Now, regarding XOR operator, we know that it will satisfy associative law. You can perform among any 2 variables first and then with third variable. So you can rearrange this one. Right. So Q XOR Q is what? 0. That means X exclusive or 0 is nothing but X. See, circuit seems to be very complicated, but once if you know the basics of or the concept that you learned in 3rd chapter, with the help of that, when you got to know this overall circuit is XNOR, after that, with the help of currently whatever first method we have discussed in this chapter, with the help of that logic, you are getting the simplified equation like this. So after doing the simplification, we got the characteristic equation as Q of T plus 1 equal to X. That is matching with what? D flip-flop. If X equal to D, then it is D flip-flop. So option C is the correct answer. Okay. Option C is the correct answer. In this way, you can solve the questions whenever you are having one flip-flop, okay, and with the help of some logic gates or feedback mechanism, etc. Whatever the first method we discussed, that is the method you have to follow. Okay. In some question, they can ask what is the resultant circuit, or in some question, they can ask what is the state that you are getting, like after applying so and so clock pulses, etc. So this is one method of solving these kind of like questions in the sequence circuit. Another method, whatever I have discussed in the previous question, like that. Say for example, tabular form. Yeah, you can observe the previous question, shift register. Similarly in counters, most of the questions you can solve with the help of tabular form method, and some questions you can solve with the help of first method. Some questions you can solve with the help of both the methods. But whichever method, with the help of that, you can solve the question less time, according you can apply, definitely you can save the time in the gate exam. Okay, right. Now the next question. Yeah, just observe here, you are having 4 D flip-flops. You are having 4 D flip-flops. For every flip-flop, clock signal is same. See, whenever you are solving any question in the sequence circuit, especially when multiple flip-flops are there, first and foremost step, you have to observe whether clock signal is same for all the flip-flop or clock signal is different. Okay. Here in this case, clock signal is same. And output of one stage we have given as input for other stage. And that means here, this particular configuration is nothing but what? Shift register only. Okay. Here, input you are giving serially and output you can access parallelly. That means serial and parallel shift register. Right. But here, serial input you are getting from the output of this XOR gate. This XOR gate. Yeah, here question seems to be like little bit tough, but actually whatever the concepts that you learned already in your notebook, whoever might have studied already this subject very well, with the help of these questions, I am going to reveal what are the concepts that you have learned already. That is the beauty of the questions that I am covering in the live sessions regarding gate score booster for the subject digital circuit. Okay. So, but all these catchy points, if you can apply wherever in the typical questions, wherever like the possibilities are there, if you can apply. See, when you're solving this question very first time, you may feel tough. I'm agreeing. There is no doubt in it. But after attending the, after listening the explanation part of this question, whatever typical questions like this, then when you are getting similar kind of question in the gate exam, damn sure you can solve the question easily. Okay, that much I want to make sure here with the help of this series. Okay, right. Yeah. So just observe here. Just observe here. You are having XOR gate. Okay. One input is 1, other input is Q0. So 1 XOR Q0 is what? 1 XOR Q0. 1 XOR Q0 is nothing but what? Q0 bar. 1 XOR Q0 is nothing but Q0 bar. Yes or no? Right. Now what is this? What is your observation point? Very simple. Here you understood that it is a serial and parallel shift register, and the last stage complemented version. See, forget about this whole configuration. Now, with respect to last flip-flop, normal output means Q0, but here complemented version of that one you are giving as serial input. Now, whatever the counters you might have studied regarding sequence circuit, with the help of just by observing name of counters, can anyone tell what is this whole configuration? What is the name of this counter? With the help of D flip-flops, you have studied two counters, right? One is ring counter, another one is Johnson counter. Now tell me, is it ring counter or Johnson counter? I have given the clue. See, ring counter means what? The normal output of the last stage will connect as serial input. Okay. Whereas Johnson counter, twisted ring counter, the last stage complement version will give as serial input. Okay, that means it is a 4-bit Johnson counter. That is the first observation point. 4-bit Johnson counter. Four-bit Johnson counter or 4-bit twisted ring counter. Both are one and the same. 4-bit twisted ring counter. Okay. So for the ring counter, the mod number you are going to get. Mod number you are going to get. Or in other words, mod number means very simple. With the help of given sequence circuit or counter, what is the maximum number of unique states that you are going to get? That's all. That is the mod number. Okay. So for the ring counter means whatever the number of bits you are having or number of flip-flops, exactly same number of states you are going to get. Whereas Johnson counter or twisted ring counter, number of states you are getting double when compared to the ring counter. Okay. So here in this case, mod value is going to be 2 times 4. That means directly I am writing mod 8. Mod 8 twisted ring counter or Johnson counter, whatever. Yes, very good. Mod 8 counter. Okay. See, up to here, see, when you have studied the Johnson counter, suppose 4 bits case or 4 flip-flops, then Q0 bar directly you have connected. But if I give like that, then you are solving question regular method, right? Regularly, direct question. There is no suspense or surprise. But the same thing I want to touch with the help of like this, whatever configurations I have mentioned. So here conclusion point is very simple. Whatever the concepts you learned already, wherever they are giving such kind of questions like this, you have to try to recall and apply wherever there is a possibility. Fine. That's why, as I told earlier, in general, for every chapter, with respect to whatever subjects I am teaching in the Get Score Booster or in, okay, in general, I will follow regular sequence only. As I told, even in this digital circuits also, right from first chapter to last chapter, except this chapter, remaining all the chapters I discussed in sequence. Only in this chapter I kept random. The reason is I want to make sure, as I told earlier, how much you are very much dynamic and actively participating and trying your level best to get the correct answer, or at least trying your level best to solve the question, or at least to try to understand the question very well. Okay, because overally, as I mentioned earlier, either 2 methods or 3 methods, that's all. That is the only reason. You should not have any bifurcation that currently you're solving question of latch or flip-flop or resistor counter, whatever may be the name of the circuit, irrespective of that method of solving, either 2 or 3, that's all, standard methods for solving most of the questions I meant to say. Fine. Right. Now we understood that mod value is 8. Now what is the question? You are having initial state like this. Now the question is, for this particular circuit, initial state they have given like 1,000. What they're asking? The given circuit will never enter into. Never enter into which of the following state. Okay. So very simple. When you understood that it is the mod 8 Johnson counter, definitely it will produce 8 states. But in general, when you're having 4 bits or 4 flip-flops, you are going to get 16 possible states or 16 possible combination of zeros and ones, among which, with the help of the circuit, you are getting 8 states. That means remaining 8 states you are not at all getting. Among that, here the question is MCQ, definitely one among the 4 choice, whatever you are having, one particular state, the circuit is not entering, that particular option you have to figure out. Okay, so very simple here. See, just like earlier, you can, like, if you want to solve this question, just like, yeah, exactly like this model you might have learned. Okay, like that you can proceed. But like first column is clock pulse, then serial input, in this case Q0 bar, whatever the last stage, normal output, complement version, then 4 outputs. Like that you will be continuing. But now, just to save the time, I'm following the tabular form method, but I'm not writing everything like exactly same way whatever I discussed in the earlier question, right? But here I'm giving another clue how you can solve such kind of questions in the GATE exam in less time. Okay, first of all, you can consider like whatever the 4 bits you're having, 1,000, that you can copy. That is the initial state, right? 1,000. Now, what is happening? Overall conclusion point is what? The last stage complement version we are giving as serial input, that is observation. After that, whatever these 3 bits are there, that is getting right shift. This is the observation, because here shift register, right? And serial input you are getting from here, and that serial input is what? Complement version of Q0, correct? Now with the help of this logic, 0 bar is what? 1, then 100, then 0 bar is what? 1, then 0 bar is 1, then after that 1 bar is what? 0, 1 bar is 0, then 1 bar is 0, then 1 bar is 0. After that, if you continue, you will be getting 0 bar is what? 1, the first state. So in this manner you have to solve in the GATE exam. Then only you can solve maximum number of questions whatever possible. It's not that whatever the method of solving you have learnt in the very beginning, if you are following exactly same method in the actual GATE exam, you cannot solve maximum number of questions whatever possible for you. But in the competitive exams like GATE, you should know ways and means how to maximize your score. That is the reason, as the name title itself, GATE Score Booster, right? In order to improve your score, in order to boost your confidence, knowledge, etc. So this series of lectures are going to help you. Okay, yesterday and today, whatever we are focusing regarding digital circuit subject, definitely whoever attending live session or whoever watching these sessions in the recorded, definitely each and every student can get maximum, like they can perform well in terms of knowledge, in terms of confidence. Everyone are able to get to whatever the level, best level they can get. Okay, right. So now just observe, these are the 8 states. With the help of this counter you are getting. Now just have your observation. 4 ones, yes, we are getting. 4 ones is there. 4 zeros, yes, that is also there. Then 0 1 0 1. Are we getting 0 1 0 1? No. 0 1 0 1 we are not getting. What we are getting? 0 0 1 1. Yes, we are getting. 0 0 1 1 we are getting. Right? So that means here option C is the correct answer for this particular question. Option C is the correct answer for this particular question. Yeah, Suganya, which part you are having doubt? Yeah, regarding gate score booster for digital circuit subject yesterday and today. Okay, if you are from EC electrical IN, then next week we are teaching, I am teaching regarding network theory subject exactly similar days, like Thursday, Friday, I am going to come on the live. Okay, if you are from EC electrical IN, you can attend network theory subject. Like that, in the upcoming weeks, like control system and signal system, Vipin sir will be discussing the questions, right? Like that, in this particular month, weekly basis, one week, one subject we have planned. Okay. So regarding digital circuits, 5 to 8. Similarly, network theory also 5 to 8. But other subjects, the timing will be, I think around 9 it will be there. Okay. But anyway, you people can see, like as I mentioned earlier, if you subscribe our YouTube channel and then click on the bell icon, so that definitely you'll be getting instant notification. So accordingly, you can get the update, so you can attend live. Okay, no problem. But suppose due to any reason, if it's not possible to attend live, you can watch the same session recorded. No problem. Yeah. Yeah, next question. Yeah, Suganya, it is very simple. Like as I mentioned, this is the actual method is this one, right? See, clock signal, you will be writing first column, then serial input is Q0 bar, then Q3, Q2, Q1, Q0. Like this, you have to follow this tabular form method. But instead of discussing this one, what I have done, very simple, the same thing I have mentioned here in short. Okay, whatever the 4 outputs you are having, Q3, Q2, Q1, Q0, that I have represented, and here shifting operation only taking place. Yes or no? See, just observe. Forget about all these flip-flops. Just consider one flip-flop. What is the characteristic equation? Q of t plus 1 equal to what? D. What the moment you are giving respect to positive edge, whatever the D input is there, that is coming here. Right? Because all the flip-flops are having same clock signal, that means whatever the earlier input you are having, you are getting here. Whatever the earlier input here, whatever the earlier input here. That means very simple. Q3 is coming here, Q2 is coming here, Q1 is coming here, and here Q0 bar is coming here. So when you understood that one, here these 3 bits are getting right shift, right? Then LSB is getting complemented and coming here. Okay, I'm just discussing here once again. So 0 is getting complemented and coming here, and these 3 bits are getting right shift. Then 0 getting complement here, then these 3 bits are getting right shift. 0 bar is 1, 3 bits. 1 bar is 0, 3 bits. 1 bar is 0, 0, 1, 1. 1 bar is 0, 0, 0, 1. 1 bar is 0, triple. I hope it is clear now. Yeah, I hope it is clear now, right? Yeah. Now in this question, what they mentioned, the given circuit is not entering into which state. So you are observing choice by choice, whichever combination not at all occurred here, that option is going to be the correct answer for this question. So the sentence framing is also very important. In some questions, say for example, if they want, they can keep same question as MSQ. Then they can ask that identify the states whichever this particular circuit is producing. Then like whatever the 8 states here you're having, among these 8 states, any 4 states if they have given, you can mark all the 4 choices correct. Okay, right. Yeah, next question. Just observe the circuit. Just observe the circuit. Try to identify this counter is which counter. Yeah, just observe here. Just observe here. You are having T flip-flops. Okay. And only first stage external clock we are giving. For other stages, output of one step we are giving as a clock. That means it is a ripple counter, asynchronous counter. And for every flip-flop, T value is 1. That means it is the binary counter. There is no doubt in it. But whether it is up counter or down counter, that we have to decide. Very simple. Like for every flip-flop, corresponding edges are negative. Okay, regarding whatever the clock signals here you're having. And normal output if you have connected, then that circuit will become up counter. But in this case, instead of normal outputs, configuration is complement version. That means very simple. Just for easy understanding, I'm writing. Here, in this case, Q0 bar. In this case, Q0 bar, whenever it changes from 1 to 0, whenever it changes from 1 to 0, then only Q1 will get complement. Okay, so Q0 bar changes from 1 to 0 is as good as Q0 changes from 0 to 1. Are you agreeing or not? Just confirm. Say for example, if Q0 bar is 1, that means Q0 value will be what? 0. 1 bar is what? 0. Next, if Q0 bar is 0, that means normal value is what? 1. That means Q0 bar they have given as a clock, that is negative edge, that is as good as normal output means positive edge. That means for every flip-flop, if you connect the normal output, and every flip-flop, if you are using negative edge, then that counter is up counter. But because here positive edges you are getting. See, regarding first stage flip-flop, completely it is the optional whether you are considering positive edge or negative edge, irrespective of that. But overall circuit, since when you are having n stages, when you are using all are negative edge, for uniformity we are using here also negative edge. But similarly, if you are using n number of stages, other than first stage, remaining all the flip-flops, if you are using positive edge, for uniformity we are using here also positive edge. But whether you are using positive edge or negative edge in the first stage, it doesn't make any sense. Overall circuit will behave based on remaining stages clock signal notation. Okay, now here this given circuit is down counter. Yes, very good, Sugandha. This is the first and foremost observation point. So the given circuit is 3-bit binary down counter. 3-bit binary down counter. Just for reference, you can mention ripple counter also. Okay, right. 3-bit binary down counter. So definitely you are getting 8 possible states. 2 power 3, 8. So mod 8 down counter. Mod 8 down counter. Right? Okay. Now what is the question? Initially you are having this state. After applying 123 clock pulses, that means 123 clock pulses, whatever state you are getting, for that state you have to convert in decimal. See, currently we are solving the question of sequential, but I have combined one of the concepts that you learned in the first chapter. That is the beauty of our subject. So once again you can perform modular division operation. So here after applying 123rd clock pulse, you have to find out the state, and we understood that the given counter mod value is 8. 8 15s are 120. That means remainder you are getting 3. So very simple. After applying third clock pulse, what is the state you are getting? Exactly same state after applying 123rd clock pulse. Okay, now here initial value given 111. So 111 is nothing but what? 7. So you have to apply 3 clock pulses. That means since the counter is down counter, so you have to decrement by 3. That means you are getting what? 4. So in the binary means you will be getting 100. Okay, just for reference here I am writing 100. And anyway in the question I clearly asked decimal equivalent, so answer for this question is 4. That's all. Okay, the decimal equivalent of state of the circuit Q2, Q1, Q0. So answer for this question is 4. See, if you remember earlier one question we already solved. Okay, but that question is what? You are having directly the binary down counter I have given 16-bit or 16 flip-flops. Okay, that initial state you are having after applying so and so clock pulses, what is the state? That time, whatever the procedure we done, exactly same. But in this question, straightforward question. But here in this question, I kept so many twists, right? Whatever the concepts, basics that you learned, if you are able to apply and if you got the conclusion point, then accordingly you can get all the conclusion points. But somehow or other, even though you know early, but while you're solving, if you forget, don't hesitate. Whether it is up counter or down counter, somehow that you understood that it is a ripple counter because t value is 1. Very simple. If you want to decide it is a up counter, suppose you want to verify, you consider initial state as 000. After applying 1 clock pulse, whether value is incrementing by 1 or decrementing by 1, just observe. Suppose if value is incrementing by 1, that means 000 is there. Now value got incremented by 1, that means 0 become 1, that means it is the up counter. Suppose if you want to decide down counter, then consider initial state as 111, just apply 1 clock pulse, then decide, just have observation whether value is decrementing by 1 or not. If the value is decrementing by 1, that means 111 become 110. That means with respect to Q2, Q1, Q0 I am talking. Some students will be so smart because I told this point, they will be observing Q0, Q1, Q2. No, Q2 is the MSB, Q2 is the MSB, Q0 is the LSB. That is the most important. Whenever you are having binary number like this, definitely leftmost bit will be MSB, rightmost bit is LSB. There is no doubt. But coming to the ripple counter or asynchronous counter like this, Q2 is MSB here, last stage you are getting, and Q0 is LSB. Okay, see, all these important note points you have to focus while you are solving the questions. Okay, right. Yeah, so far we have discussed up to 5th chapter. Whoever from CS branch, so we completed the syllabus part regarding digital circuit subject with the help of this question, right? Whoever from EC electrical IN, we are having further more questions now. Okay, now we are discussing the questions regarding data converters, right? With respect to electrical branch, the syllabus is up to this particular 6th chapter. Okay, right. Yeah, now we are going to discuss the questions regarding data converters. After that, we will be discussing the questions regarding last chapter as well with respect to EC and instrumentation. Yeah, so this is the question based on digital to analog converter, binary weighted resistor type DSC. Okay, now here in this question, they have given LSB, the resistor correspond to LSB. See, it is a 4-bit binary weighted resistor type digital to analog converter. The resistor value corresponding to LSB. Resistor value correspond to LSB given as 2K. Now the question is resistor value corresponding to MSB. See, you don't need to by heart anything, very simple. I hope you might have one important point when you have studied this particular circuit, this particular concept when you have studied, you might have observation regarding the resistors. Okay, you are having the resistor values you are having in powers of 2. That is the reason here the word binary weighted resistor type. Okay, very simple. Since in the question clearly mentioned it is a 4-bit, so just consider 4 bits. And if the with respect to unsigned case, you know the position weights in powers of 2, like 2 power 0, 2 power 1, 2 square, 2 cube. And just by observing position weights, you know that this position weight is having least value. Definitely this is your LSB. And this position weight is having maximum position weight. So that means this particular bit is nothing but MSB. Up to here, you know very well. As I told in the earlier question also, like when you're having Q2, Q1, Q0, Q2 is the MSB and Q0 is the LSB. Correct? Right. So this understanding you know up to here. Now coming to this particular circuit, binary weighted resistor type DSC, what we have to do? Very simple. Whatever the position weights here, those position weights we are multiplying with one resistor, right? And now we are doing little twist here. What we are doing? See, this particular, whatever the resistor you are having, 2 power 0 into R, that resistor value we are giving for exactly opposite. This bit you know, that is LSB, but this particular weight we are giving for MSB resistor. Okay. 2 power 0 into R, that is nothing but R. Similarly, this bit you know, that is your MSB, but this particular positional weight multiplied with resistor that you are giving for LSB resistor. So here in this case you are getting 2 power 3 into R, that is nothing but 8R. Now in this question, see, no need to by heart, as I mentioned earlier, very simple. You just consider what are the number of bits they have given, accordingly keep the LSB position weight and MSB position weight. LSB position weight multiply with resistor that you are giving for MSB resistor. Similarly, position weight of the MSB multiply with resistor, and that one you are giving for LSB resistor. Exactly, just you are doing swap. That's all. Now in this question they have given LSB resistor, that is 2K. Okay, so from here what you are getting? R value as 8R divided by 2K. In general you will be doing simplification, but here in this case if you observe, 8R equal to 2K. So just one second. Yeah, so from here what you are getting? R equal to 2K by 8. Yeah, 2K by 8. Right, here just have observation, like 2K by 16, 2K by 8, 1632. That means normal numbers are there and division operation is there. So here R value is nothing but 2K by 8. Okay, so here R value is nothing but MSB resistor. That one only we are asking. The resistor value correspond to MSB. So that means you are getting option B. Option B. Yes, very good, Suganya. This is a question based on weighted resistor type DSC. Okay, now the next question I am showing. So here you are having R2R ladder type DSC. Okay, but in this question, see, when you are having such kind of questions, if you know the standard equations, accordingly you can solve. That is one approach. Or whoever studied analog circuit subject, especially op-amps very well, definitely with the help of that logic also you can solve. Currently I am discussing with the help of op-amp based questions, whatever you might have solved in your analog circuit, that approach I am touching here. Okay. Yeah. So here just observe, here 0 volt means what? Ground only. Okay, here 0 is there, that means it is ground only. Fine. Here also 0, that means it is ground. Okay. So here in this case supply voltage given. Fine. Now just observe, here these two resistors are connected in series, that means 2R, and this 2R connected in parallel. Yes or no? That means here you are getting equivalent resistance as R. After that R series, that means you are getting here 2R. Up to here just confirm. If you have any doubt you can ask immediately. I am going little fast. The reason is you know this concept very well. Okay, regarding equivalent circuit, like series connection means addition, parallel connection means like R1 R2 by R1 plus R2, like that. Okay, since you know that, that is the reason I am just discussing fast. But if you are having any challenge, then you can mention immediately. I will be discussing slowly, no issue. Yes, very good, Suganya. Excellent. Yeah, I hope you are able to understand. Great. So here as of now we got here 2R, then parallel with 2R, that means R series, that means you got 2R as of now. Now whatever you got till now, I am just drawing part of circuit. Like here you are having 2R. Okay, now that 2R is connected to ground. Okay, I will represent like this, no problem. Yeah, 2R is connected to ground. Whatever this 2R, that was present between this point and then ground. Fine. Next here you're having 2R, and then you're having supply voltage V. Okay, supply voltage V is there, so I'm representing voltage source here V. Right, now this part of circuit you're having. Okay, see, forget about this part of circuit, just remove this circuit, then this terminal become what? Open. Okay, now this circuit you can represent as the equivalent Thevenin circuit. Thevenin's equivalent circuit you can represent in the simplest format. Okay, so in order to find out the Thevenin's equivalent circuit, you have to find out the open circuit voltage or VTH. Okay, between these 2 points voltage is nothing but across this 2R voltage. Now, since no current flows here, then these 3 elements are connected in series. In series, current will be same, but voltage getting distributed. Here, since voltage V is there and resistors are having equal value, half of this voltage you are getting here, the same value you are getting here also. That means, very simple, across this 2R, voltage is nothing but V by 2. That is your VTH or Thevenin's equivalent voltage or open circuit voltage, all are one and same. And similarly, when you calculate RTH, you will be getting voltage source, you will make it a short, then 2R connected in parallel. 2R connected in parallel, that means you are getting R. So that means very simple, what you got. Up to here, whatever the part of circuit you are having, this part of circuit you can replace as a voltage source V by 2 in series with one resistance R. Okay, right? So I'm just writing here. You are having one voltage source, that is your V by 2. Okay, instead of representing voltage source, I have labeled that voltage value V by 2. V by 2 in series with R. V by 2 in series with R. Now, here you just observe. Here you are having R. Yeah. And then here 2R is connected to ground. Here 2R is connected to ground. Yeah. So just observe. Up to here we got equivalent circuit as V by 2 in series with R. V by 2 in series with R. Now I have considered this circuit R and then this resistance 2R. Now once again I am just analyzing up to here what is circuit you are having. Once again, just like here, simplified Thevenin's equivalent circuit. Simplified Thevenin's equivalent circuit. Now, in this case, just observe. R are connected in series, that means 2R. Now, across this particular terminals, you have to find the voltage and just observe. Voltage source in series with 2 resistors. Okay, equal resistors. Just like here, whatever we discussed, equally getting distributed, right? Exactly V by 2, half of that. That means V by 4 here, V by 4 here, right? So here in this case, you are getting V by 4 voltage, V by 4, right? And coming to the RTH, here if you calculate, okay, just for reference here, I am mentioning RTH1. Here, because it is a case 2, I am writing here RTH2. Okay, in this case, once again, 2R parallel, 2R parallel, that means you are getting 2R parallel with 2R, that means R. That is the beauty of R2R ladder network. When you are adding 2 equal resistors R and R, that means resultant equivalent resistance is 2R, but if R and R parallel are 2R parallel, that means equivalent resistance like half of the original. Okay, to do the calculation simpler, that is the reason we are having R2R ladder network. Okay, now what we got, very simple. Like up to this portion, whatever the overall circuit you are having, that entire circuit you can replace as V by 4 voltage source in series with one resistance R. Okay, yes, very good, Suganya, very good, excellent. Okay, so whatever so far we got, that one I am just representing here. Okay, I am just adding one slide. Yeah, so here we got V by 4. Yeah, V by 4 we got. Then it is in series with one resistance, that is your R. Now, whatever the rest of the circuit you're having, you can append. Here you're having 2R and then op-amp. 2R is there. Yeah. Then op-amp. And here one feedback resistor is there. Yes. Feedback resistance values are, and here the final output is V0. Okay, and the current flowing in this particular direction is I. Okay, so here in this question you have to find out that current I. Okay, just you can apply KCL, that's all. Just you can apply KCL at this particular node. Just apply KCL at this particular node. Okay, so see, I hope all of you know this concept regarding virtual short. Here for the op-amp at the positive terminal, whatever the voltage you're having, exactly same voltage you're getting at the negative terminal or inverting terminal of op-amp. So since here it is 0 volt, exactly same 0 volt you're getting here. Now here in this case, current is flowing like this, suppose, because voltage source here V by 4, here 0. Okay, and here current is flowing like this. Or otherwise, if you want, just like in your network theory, if you want to assume that current is flowing like this, you can consider, no problem. In any manner you can solve, no problem at all. Okay, but just apply KCL here. In this direction, the current flowing is what? 0 minus V by 4 divided by 2R plus R is what? 3R. And here current leaving I is equal to 0. You can do like this, or in other words, you just find out in this branch how much current is flowing, because op-amp is ideal, no current flows. Whatever the current is entering, exactly same current is flowing. Like that also you can do, based on your convenience. Okay, yeah. So you can write like this, or otherwise if you want to do in another way, you can do. See, I am discussing all the possible cases so that whoever beginners are there, even they can also solve the questions correctly. That is the reason I am covering, because this is the basic concepts with respect to even other subject. Okay, fine. So now here very simple, you are getting here 3R, and when you know that when you are having one resistor, one side terminal is voltage V by 4, another terminal voltage 0, definitely current, actually current is flowing like this. When you know that current actually flowing like this, okay, current actually flowing like this, that is nothing but V by 4 minus 0 divided by 3R. That means from here you are getting V by 12R. And since you know that in the input terminal of the op-amp, no current flows, whatever the current is entering, the same current is going. That's all. That's all. That means here you are getting I equal to V by 12R. Okay, so that is there in option B. Currently you are solving the question of digital only, but with the help of this question, at least one op-amp based question, that you got the opportunity with the help of this session, whoever from EC electrical line. Okay, how to solve the question of op-amp based circuit. Okay, right. Yeah, next question. This is a direct question based on the one of the parameter of digital to analog converter. So here in this question, it is whatever the statement or condition given, you can use. Okay, then you can solve the question correctly. Yeah, the resolution of DAC. Resolution of DAC is what? VR by 2 power n. Resolution is equal to VR by 2 power n. Okay, right. But in this question, what it mentioned, resolution of a DAC is equal to, is approximately 0.4% of 0.4%. Percent means what? By 100. 0.4% of what? Its full scale range. Full scale voltage or reference voltage, maximum voltage, all are one and the same. So you can consider 0.4% of VR. That's all. Okay. Now from here, what you are getting? VR anyway is getting cancelled. VR is getting cancelled. Now 1 by 2 power n is equal to, so this one I am writing like 4 by 0.4, you can write as 4 by 10. So that means 4 by 1000 you are getting. Now 4 here 250 times. That means from here you are getting 2 power n equal to what? 250. Because numerator 1 and 1, correct? Denominator values you can equate. 2 power n equal to 250. That means how many bits are required? N value is going to be what? I hope all of you can answer. 8 only, correct? Yes, sir. 2 power 8 is what? 256. So here, with the help of 8 bits, you are getting 256 values, 0 to 255. So 250 obviously you can represent with the help of 8 bit. Okay. So here answer for this question is option A. Option A is the correct answer. Right? Okay. Next question. Just read the question. I hope all of you can do it correctly. I'm giving 1 minute time. Just give it a try. Yes, very good, Suganya. Very good. Give it a try for this question. Yeah, just observe here. You're having 8-bit DSC, 8-bit digital to analog converter, right? Produces an analog output voltage of 1 volt for a digital input of this one. Okay. Now, what is the question? What is the maximum analog output voltage? Maximum analog output voltage that can be produced by this DSC. That is the question. Okay. I hope all of you know the formula regarding analog output voltage of a DSC. Okay. V naught equal to what? Decimal equivalent of binary into resolution. Decimal equivalent of binary into resolution. Okay. So now just observe for this particular number. When you do grouping of 4 bit, then you are getting corresponding hexadecimal digits. Okay. So here what you are getting, 0011 is nothing but 3, then 0010 is nothing but 2. Okay. So 32 is in hexadecimal. Convert into decimal by placing the positional weights in powers of 16. Already we discussed number system questions yesterday, first chapter only, right? Now with the help of 6th chapter, you are getting recap of first chapter also. Okay, right. So 16 3s are 48 plus 16 power 0 is 1 into 2. That means you are getting 50. So here decimal equivalent of binary, you got 50. Okay, for 50, you got analog output as 1. Now the question is, for maximum analog output voltage, how much you are getting? Yes, very good, Suganya. Excellent. Very simple. If you want to get maximum voltage, that means all the bits should be 1. All the 8 bits should be 1. Okay. All the 8 bits should be 1. That means when you do grouping of 4 bits, you are getting hexadecimal digits. That means here in this case, you are getting FF base 16 is nothing but what? 255. I hope all of you are familiar. Now the logic is very simple. Here it is like once up to here to get the equivalent decimal, it may take time, but once if you got this much, after that the question is nothing. See, very simple. When you are having 50, for 50 you are getting output voltage 1 volt, correct? Now the question is for 255 how much you are getting. That's all. Just do the cross multiplication. Okay, so if you do, then what you are getting? 255 into 1 divided by 50. So just do the simplification. From there you are getting 5.1 volt. 5.1. Yes. See, simple logic. If 0 is not there, then 551 times, but 51 divided by 10, that means 5.1. That's all. Okay, that is there in option D. So option D is the correct answer for this question. In this way, some questions are easy to solve, but only thing you have to understand. For understanding the question, it may take time. Okay. Yeah. Now the next question, that is the question. I hope all of you can answer the question just like that. The moment if you read the question, you can instantly, just like the question, simultaneous, right? Yeah. Simultaneous ADC. Simultaneous ADC is nothing but parallel ADC or flash type ADC, all are one the same. Okay, just for reference, I'm writing simultaneous ADC, simultaneous ADC or parallel ADC or flash type ADC, all are one the same. Parallel ADC or flash type ADC, all are one the same. All are one the same. So here in this question, you are having 6-bit flash type ADC. The number of comparators required. That means minimum number they are asking. Number of comparators required. So very simple. The formula is 2 power n minus 1. So in this case, n value is 6. 2 power 6 is what? 64 minus 1. That means 63. 63 comparators sufficient. Minimum number. But if you want, you can implement with the help of 64 comparators also. But minimum number is what? 63. Yeah, up to here we have covered the questions up to 6th chapter. So with this question, we have completed the syllabus for electrical students also. Okay, now whoever from EC and instrumentation branch for digital circuit subject, we are having one more chapter, that is CMOS logic family. This is the last chapter for digital circuit subject. Okay, right. Now we are going to discuss regarding CMOS logic family based questions and whatever miscellaneous concepts, semiconductor memories. Regarding that also, we are going to cover few questions here in this session. So with the help of that, we will be concluding in some time with respect to EC branch and instrumentation branch. Okay, right. So regarding CMOS based circuit, whenever you are having one circuit, you can how to identify? Very simple. This configuration, you know, regarding representation by symbol NMOS transistor, and here like you will be having multiple symbol representation that you might have learned in the analog circuit subject. Okay, regarding NMOS transistor, PMOS transistor. So in some questions you will be having like this arrow symbols won't be there. So normal lines only will be there, that is your NMOS, and here bubble will be there, that is PMOS. Another configuration is what? Here source terminal, like arrow direction is coming like from here like towards outside, whereas here inside. That means outside is indicating NMOS transistor, inside indicates PMOS transistor. Fine. This overall circuit output expression you have to find out. Now the most important point, whenever you are solving like these questions in the CMOS, the first and foremost observation, first and foremost important point, the output expression by default you will be getting in the complement version. That is the first and foremost. So you have to represent that one. Because how to, sir, why we are getting complement version? Very simple. With the help of one transistor I am discussing. Okay. Say for example, forget about this whole circuit. When you are having one NMOS transistor here, when this transistor is on, when you have given to the gate terminal logic high or 5 volt, okay, then this transistor is on. Transistor NMOS on means drain and source are shorted. That means output line connected where? Ground. You have given 5 volt as input, but output you are getting ground. That means it is a what? Complement version. So that is the reason, first and foremost, when you are having CMOS circuit, output expression represent complement version. Don't forget this. Don't forget. Okay. Now after that, very simple. Just focus here between the output and ground. You are having NMOS transistor. Between supply and output, you are having PMOS. Okay. With the help of this network, you can write the expression. Okay. Now just observe here these two transistors, how they are connected. Parallel. Parallel means what? Logical. Parallel means logical among the variables. Okay. A plus B. Now here you got one single resistor. Now that you got one single transistor NMOS. That transistor and this transistor, how they are connected? Series. That means logical. Very simple. Whatever you might have learned series connection means logical and parallel connection means logical. In the second chapter, that concept only we are applying. Okay. Up to here you understood. Now, these three transistors we have done into simplified form. We got one single transistor. Now that NMOS transistor, this NMOS transistor, how they are connected? Parallel. That means logical. Logical. Here the variable is D. Our input is D. Now just observe. A plus B into C plus D whole bar. Yes, that is there in option C. But suppose if you miss this complement, that is also there in one choice. That is there actually in the first choice. Okay. If the exam paper setter is smart, because of the silly mistake, what option you may choose as the correct, that one they will keep intentionally in option A. Many of the cases. Okay. Because in hurry, if you forget the complement, because of that, that is there in the option A. In the exam, you may say, matlab in hurry, you may choose as correct, but after seeing the answer key, you are getting demotivation or confidence level is going down. Okay. But don't be in hurry whenever you are solving any question. But at least 5 seconds you can have patience in the actual GATE exam time and have a cross check with respect to the given circuit or context based, whatever the context is there as per the given data, whether your final answer is correct or not. Just have a cross check. 5 seconds if you are having patience, then definitely you can, whatever silly mistakes many of the students may do in general, you people can overcome. Whenever, I'm not saying that for every question you have to cross check, need not be, but if you are having 100% confident about your answer, you can attempt. But whenever typical questions are there, at least you can have 5 seconds patience and have a cross check just for verification. Like let us consider one input combination substitute, whether whatever the value here you want to choose with respect to that combination, whether circuit is producing or not, just have a cross check. Then at least you are getting that hint that option A won't be correct, option C is going to be correct, like that. Okay. Just like now also, because live session as per the planned time is 3 hours, but because currently we are running off the time, like some people might be thinking that when SAR is going to complete, right? So like that mindset, some people will be having exactly like in hurry mind, okay, in the GATE exam. So, but when you are learning the concept, you should always have the patience. See, in the GATE exam also, you should have speed while solving the question. But where I want to address, your speed has to be little reduced while marking the option. That time have a cross check 5 seconds. If you have cross check, then definitely you can overcome. Okay, what is silly mistake? In general, you may might be because of silly mistake or misconception or misunderstanding about the given question, wrongly assumed, etc. Whatever the, because of whatever factors whatever the marks you are supposed to get, if you are losing, you can overcome that kind of challenge. Okay, right. Yeah, next question, very interesting one. Very interesting one. So you are having one Boolean function. For implement this Boolean function, how many NMOS, PMOS transistor pairs required? Very simple. Just have observation of earlier circuit. See, whenever you are having CMOS based circuit, how many NMOS transistors you have used? Exactly same number for PMOS. That means together we are calling it as a pair. That's all. Okay, right. So that means, say for example, in this question, if you observe 1, 2, 3, 4, 4 NMOS is there, 4 PMOS is there. That means together 4 NMOS, PMOS transistor pairs are there, like that. Okay. So here circuit wise I am not drawing, but logic wise I will be discussing. Okay. See, as I have discussed earlier, whenever you are focusing CMOS circuit, by default you are getting what? Overall function as complement. That is first observation. Now, whatever this whole function is there, overall function we don't have complement. So that is the reason first and foremost you have to represent overall function as complement. But if you put one complement, that is not equivalent for the given function. So you have to put double complement. Suppose if overall function is complement, then you no need to introduce. Okay, fine. Now up to here you understood. When you perform 2 times complement, you are getting original function. Okay. Now what is the function given? Now you can consider. Whatever the function you are having, you can consider. ABC plus A plus B plus C whole bar. Right? Okay. Right. Now what you have to do? Very simple. What we have told is, with the help of CMOS circuit, overall circuit function you are getting output in the form of overall function as complement. That is your observation. That means overall function you are getting complement. Yes, that you are getting here. Now, whatever here you are having inner complement, you can apply De Morgan's law. Okay. Now, x plus y whole bar is nothing but x bar into y bar. See, this concept you learned in the second chapter. With the help of this question, you are getting the recap of second chapter. Fine. ABC whole bar. Then here a plus b plus c complement you are having, and once again here complement is there. Okay. See, very simple. This expression itself is having complement. By using De Morgan's law, you are getting one more complement. Okay. Now external complement you can keep as it is. Yes. So now just focus here. Up to here, if you got, that is more than sufficient. More than sufficient. See, first and foremost observation, overall expression you should have complement. Yes, it is there. Now after that, just observe here. Forget about this term. Forget about this term. You are having what? You are having ABC whole bar. ABC whole bar. That means you require 3 NMOS transistors, right? Say for example, just observe. Like 3 NMOS transistors you can connect in series here. Then output expression you are getting what? ABC whole bar, right? Like that, with that understanding, I am telling here, regarding ABC whole bar, we require 3 NMOS. That means 3 PMOS. Okay, there is no doubt. Now, just observe. A plus B plus C whole bar. See, here in this case, NMOS you are connecting in series. That means PMOS will be in parallel. Circuit wise not important, but focus is how many NMOS required or how many PMOS are together pair, right? Now, here A plus B plus C, that means 3 variables are there. So 3 NMOS you are connecting where? In parallel. Okay. So here you require 3. Now, whatever here NOR gate you got, that output you are passing through CMOS inverter. That means here you require one more. Here you require one. Up to here, any doubt? See, for implementing this expression, we require 3 NMOS. For implementing this expression, we require 3. And for implementing here complement, we require one more. That means here, as of now, we are getting 4. Here 3. Up to here, fantastic. There is no doubt. Now, whatever this circuit you got output, very simple. This is the NAND gate output, this is the OR gate output. That's all. Okay. After that, this circuit output, you have to pass through. Just treat like this is X, this is like Y. XY whole bar, right? So just for easy understanding, whatever the whole expression you got, you treat like XY whole bar. Then here, overall function you are having complement. Yes, you are getting at the output of CMOS circuit. Now, under the complement, you are having 2 variables. That means you require 2 NMOS. You have to connect in series. That means very simple. This output you are passing through. For one NMOS transistor, you are connecting to gate terminal, and this output you are connecting to one more NMOS transistor gate terminal. And those 2 NMOS you have to connect in series. Right. Now just have a count. 3 plus 4, 7, 7 plus 2, 9. Okay. The final answer for this question is this is a very, very interesting question. In general, many students will get, other than this answer, different answers. Yes, I hope all of you felt this question is one of the very, very interesting question. Okay, right. Yeah. So with this, we have completed almost regarding CMOS logic family. Now we are discussing miscellaneous questions regarding semiconductor memories. Okay, this is a theoretical question and MSQ question. I hope by this time everyone might be having idea, but still some students might be forgetting. That is the reason I covered that theoretical question also here. With the help of this question, you are getting recap. RAM is volatile memory. Yes, it is true. See, volatile means what? The moment power gone, the data is getting erased. Okay. So definitely ROM is non-volatile. It is a permanent memory. For storing program, you can use this memory, right? So that means this statement is also correct. RAM, full form is what? Random access memory. And here ROM is what? Read-only memory. So with the help of RAM, you can do both reading and writing operations. So here all the 4 choices are correct. All the 4 choices are correct. Yeah. Now the last question. right? 50th question. Yeah, if the number of data lines is 8, then the number of address lines required for a 4 KB ROM. See, in general size of the ROM, the formula you are having, if you are having n address lines, with the help of that, you are getting 2 power n memory locations. Okay, you can identify that many locations with the help of n address lines. And in each location, if you can store m bits, then size of the memory is 2 power n by m. 2 power n by m. Yes, very good, Suganya. So this is the size of the ROM. Size of the ROM or memory capacity, all are one the same. Now, in this question, it is given, n value as 8. Okay. So this is nothing but size of the ROM or memory capacity, all are one the same. Okay. Size of memory or memory capacity, all are one the same. Right, in this question they have given that 4 KB ROM. 4 KB means what? 4 you can write as it is. Kilo is nothing but 2 power 10. In general, kilo is nothing but 1000. With respect to digital circuits or microprocessor, semiconductor memories, etc., 2 power 10 is nothing but 1024. It is almost closer to 1000. Okay, but exact value means 1024. Okay, but approximation wise it is closer to 1000. That is the reason, like, we will be using the notation K. K stands for kilo. Fine. Now, capital B stands for what? Byte. Byte is nothing but group of 8 bits. So you can represent. Now this is equal to 2 power n. N we have to decide. M already given. Number of data lines is 8. Now, in this case, 8 is getting cancelled. 8 is getting cancelled. Now, whatever this number is there, just represent in powers of 2. 2 square is nothing but 4 into 2 power 10. That means 2 power 12. 2 power 12 equal to 2 power n. From here, what you are getting? N value is 12. N value is 12. That's all. The number of address lines we asked, answer for this question is 2. Yes, very good, Suganya. Excellent. Yeah, just like yesterday class, whoever attended the live session, I have mentioned that time. And similarly, in this session, Suganya and other students who are attended, and Suganya got for most of the questions correct answers. I am very happy for that. And even other students also, some of the students already got correct answers for most of the questions. And whoever attended this live session and got for many questions correct answer, hearty congratulations from my side. And whoever watching this session in the recorded form later, no issue. Whoever going to solve the questions that we have discussed in this session, for many of the questions, whoever got correct answers, from my side, in advance, I am telling hearty congratulations for all of them as well. Okay. And in yesterday's session and today's session together, in both the sessions together, regarding digital circuit subject, we have discussed 50 questions. 50 questions we have discussed regarding the concepts which are important and most important for your coming GATE exam, and we have covered the models also, and important variety of questions also we have covered regarding digital circuit subject. With respect to EC and instrumentation, overall count is 50. With respect to CS branch or electrical branch, the number may come slightly less with respect to your number of chapters that you are having as per the syllabus. But if I consider with respect to ECRIN, overall we are having 7 chapters. We have done half century in the span of 2 live sessions. Yesterday we are having 3-hour session, and today we are having a 3 hour 26 minutes currently running time. Okay, so yesterday it was slightly less when compared to 3 hours. So that is the reason I have done compensation today. So overall we can say in the span of 6 hours, we have discussed 50 questions. Definitely whoever attended this live session yesterday and today, or whoever might be watching in the recorded, no issue, irrespective of that. In terms of learning experience, definitely each and every student might have got great learning regarding digital circuit subject. Whatever the thought process, how to understand the question, how to solve the question, what are the tips and techniques that we have covered in yesterday's session and today's session, definitely with the help of this, you people might have got maximum confidence and knowledge, etc. So try your level best, try to do the revision, whatever the notes you're having, practice well, definitely you can get very good result. Okay, right. Yeah, So if you're having any queries regarding digital circuit subject or general, you can mention. Meanwhile, in the chat, I will be responding in some time. I want to give some important updates here. Whoever not yet enrolled till now at our IMS Gate Academy for any of the GATE program, but if you are targeting for GATE 26, I am strongly recommending, try to enroll for Test Series Plus program as early as possible, because whatever the currently limited months you are having before your GATE exam, whatever you might have prepared already very well, some subjects or most subjects, whatever you have studied, unless otherwise you got exposure to the test environment, you never ever get the confidence such a manner you can perform well in the actual GATE exam. If you want to get, before you are going for the GATE exam, if you want to get enough confidence, definitely our Test Series Plus program is going to help you like anything. Okay, so you can observe here, you are going to get the latest 33 years GATE PYQs you are getting. So you will be getting 2 booklets. Suppose example, if you are from EC, you will be getting technical 8 subjects, last 33 years GATE questions along with solution. Along with that, regarding maths and GA, you are not only getting 1 branch questions, rather you are getting 6 branch questions. Okay, 6 branch means EC, electrical, instrumentation, computer science, mechanical, civil, right? Similarly, if you are from computer science, technical subject booklet, you are getting 33 years booklet, maths and GA, you are getting all the 6 branch questions. Okay, right. And then, so you can have here, just for reference, like for every chapter, we have mentioned in the beginning chapter overview, like all the important points. Even in solution, we have provided key points wherever note points are there, and even some typical solutions. For typical questions, we provide our video solution. Okay. So similarly, you can have the glance regarding maths, and then just observe here regarding our test series, like chapter wise tests we are having, and then subject wise tests, 3 levels are there: basic, advanced, and then multi. But I will recommend, like, you can solve. See, if you don't have that much time, at least selective chapters you can attempt, and basic subject test you can attempt. Somehow other, if you got decent content in 6 subjects, then definitely you can go for full length mock test. Okay, but advanced subject test, multi subject test, if you have time, you can do. Otherwise, no need to attempt. That is okay, optional, because the level of the question will be slightly higher side. But our motto is what we want to, you should get decent content before you are going for GATE exam, right? And you should know in which concepts you are very much strong, which concepts you have to do further revision, etc. So that is the reason this test series is going to help you a lot. Like anything, as I mentioned this one, and as I mentioned here, the PYQs, definitely selective questions you can solve, whichever easy for you, whichever moderate for you. You may not have that much time to solve every question, but I'm not recommending also, because you are having limited time. At least selective questions, if you do, at least you are getting decent confidence before you are going for GATE exam. Definitely you will feel proud when you are going to write the GATE exam. Okay, because whatever best you can perform, whatever the best you can learn, that you have done before you are going for GATE exam, right? Yeah. And so you can observe here regarding our GATE 2024 achievers. Similarly, the latest GATE 2025 achievers also, right? And if any of you, like say for example, last year you have given 1 attempt, somehow that you got decent marks, are not even qualified, but now you want to consider GATE 26 as the, you want to give very serious attempt. Okay, then at least I am strongly recommending, okay, you can enroll for SLP program, provided if you can spend 8 to 10 hours per day for watching the lectures, and daily basis if you can do revision, whatever the lectures you have listened for that particular day, still you can get very good rank in the upcoming GATE 2026 exam. Okay, but if you want to enroll for some of the classes for live also, and other classes if you want to watch for recorded, then you can enroll for live online program also. And whoever want to targeting for GATE 27, then based on your convenience, whichever program is suitable, accordingly you can enroll. And if you want to get complete details, the link, counseling session link, is provided in the description of this particular video. You people can book the free counseling session slot. Our education advisor will be discussing regarding features of each and every program in detail. Accordingly, you can take the call, whichever program is suitable for you. Okay. Yeah. Not but not the least, as I mentioned in the beginning also, whoever not yet joined our Telegram channel, so kindly join. The link is provided in the description of this video. Okay. It is free for everyone. Okay. Right. Yeah. Not but not the least, keep learning and keep growing. Try and fail, but don't fail to try. Okay. Yeah, we have discussed everything regarding digital circuit subject, whatever important models with respect to your coming GATE exam in detail we have covered. As I told earlier, we have done half century in the span of 6 hours. Definitely many of you felt that it is a great learning experience, right? Similarly, whoever from EC Electrical IN, I will be coming on live in the next week, just like in this week, Thursday and Friday, right? Exactly similar way. The next week, Thursday and Friday, timings are same, 5 to 8. I will be coming on live regarding network theory subject, GATE score booster sessions. Similarly, other upcoming live sessions, whatever is there, it will be updated in our YouTube channel. You people can kindly subscribe our channel and click on the bell icon so that you will be getting instant notification. Thank you everyone.